Look at that.
Hello, everyone. Welcome to our next episode of Science Happy Hour. We were off last week. So sad. We missed you all. I hope you missed us. But we are back now with a whopper of an episode. We're going to have some pretty deep discussion tonight. We actually made this episode a little less involved in terms of the number of segments that we normally do because we think the discussion is going to be extra deep and complicated and fun tonight.
I'm ready.
Yeah, we are going to have some gaming at the end of it. So, okay, so this is our lovely show where a group of scientists get together and talk science over a few drinks. And tonight's episode is going to be about quantum physics, quantum mechanics, quantum computing.
That's what's going on right here.
Oh, yeah. We've got all
physics.
kinds of stuff.
Right there.
Somehow.
Wow, look at that.
Right?
It's a lattice.
Yeah.
Somehow that's quantum physics.
It's a real picture
It's actually,
of quantum
so
physics right
it's a like fractal sort of representation. And the reason why I chose, they're supposed to be sort of fractals in here. So which there have been some observations of fractal-like patterns at the quantum level. So that's why I went with it. But anyway, really I just Googled physics backgrounds and a bunch of fractal shit came up. But then I was like, why does that make sense for a physics episode? And then I looked it up and found that stuff.
You're good. You're
So-
good.
You should have
I know what
had
you're doing.
shots from Interstellar.
Oh yeah,
Which is,
good
by the
one.
way, the most realistic. Those are like the most realistic simulations of a black hole.
It's
and a wormhole
true,
ever.
yeah.
They wrote papers on them. It's super cool.
Yeah, there was a researcher from UNM physics department who was a
From
consultant.
UNM?
Oh, I
Yes.
read
I
about
didn't realize
that.
he was at UNM.
Yeah, he's
We're way
from
more awesome than I
he's from
realized.
UNM. Yeah.
Well,
So
don't push it.
right here in Albuquerque. Anyway, okay, so I'm getting
I'm ready.
maybe some
I'm
info
pumped.
that
Wait,
someone
did
might
you
be
show, like,
muted.
the
Science.
desert farm scenes in New Mexico
For Interstellar?
in the beginning, yeah.
Oh, I'm not
Maybe.
sure. I mean,
That would
We
make
do
sense.
have a lot of that here.
suitably
So
dusty.
Because I was just like,
Very
why would they
dusty.
go to UNM for? No offense to UNM physicists, but
Yeah.
I mean,
maybe, yeah.
there are some really well-renowned UNM physicists here, so that's probably
Yes,
why
but there
they
are a
went
lot
to
of
them.
well-renowned physicists
Right, but like
everywhere.
maybe we have one of the best. We actually have a really good quantum computing
Oh,
segment
really?
of it. Yeah.
Oh. I did not know that.
Yeah.
Wow, this is cool.
That's so cool.
I
We
know.
should do an on location.
I know. We
thing
should
on
totally
UNM,
do that. We
right?
can definitely
Next
do
Oh,
that.
that's cool.
Yeah. So stop, giving shit to UNM. Let's be nice.
Hey, I won here. Clearly, I think it's okay.
Yeah, it's true. Okay, so sorry, we're having some. I
Can
think
you hear
maybe
mine?
you're muted. Are you muted?
Am I muted?
Let me see.
Check me.
No,
Everybody's
we're good.
missing my wit.
I don't know. It
Or
should
lack
be
thereof,
on.
I don't know.
Everything's on.
Can you test,
So test.
What's up?
Let's do some things
What's
here.
up, interwebs?
Okay.
Is
Are we?
everything okay?
How are we doing now? Any talk at a normal volume? Yeah.
Hello,
Testing.
human.
Testing. I like science.
Yay. Hopefully it's doing okay.
Okay.
All right. We'll see.
Okay.
We'll see what happens. Okay.
Anyway, quantum physics.
Yay! Okay. All right. So just to start off, I'm still kind of quiet. So sad. Okay. Me. I'm quiet. All right. I don't know.
I
Here.
know, it's weird.
Yeah. I don't know. We'll see. Okay.
Just yell.
Test.
Oh, okay. So I'm the only one they can hear. So
Oh.
weird. Okay. Here we're gonna turn up some knobs here.
We're just gonna.
How about that?
Yeah. We're just
Okay.
working on.
Hello?
We're just working on some stuff
Yeah.
here.
All right. We're good. Let's just keep
Are
going.
you good? I'm good. Are you good?
I'm
I
gonna.
have no idea if anyone can hear me. That's
All right. Tell me who you are. I'm Kate. I'm your host for this evening, and I'm going to run the show.
Oh, nice.
But who are you?
Yeah,
I'm
where are you?
Eric. I'm an evolutionary anthropologist, and I study the evolution of norm enforcement behavior in humans and how and why that varies from culture to culture.
Nice.
Cool. That is super
Cool.
cool.
Yeah. I'm Scott. I'm a chemical engineer with a degree in engineering and mathematics as well. I like Star Wars, and I got a haircut last week, so.
Nice.
Important information.
Yeah, so.
So
I think that's
how
what
low
they
is
wanted
it?
to know.
It doesn't sound like their mics are on.
They're on.
Doesn't sound
Everything's
I see
on.
levels on the. Or
Yeah.
I did see
Hello?
levels.
Hello? Yeah, I see
So
levels on
sad.
mine.
I see
I mean,
levels
it's
on mine.
showing up on
I
here.
think-
I don't know what's going
Yeah, my
on.
levels are showing up.
Test. Maybe not, though, actually.
We'll get. What about the audience? Is
And
anyone
yours
here?
keeps going.
That's probably
It's your
my
test,
hair.
probably.
I would bet that's my
Testing.
hair. So I'll just do that.
Get the scissors.
No.
You get like the office scissors haircut.
Speaking of haircuts.
Yeah.
This is
All right.
odd.
I don't know what's
yeah,
going
I don't know.
on.
I guess I'm not seeing
This might be an
levels.
issue.
Yeah, 'cause it
necessarily when I
would
talk. It spikes at
It
odd
shouldn't.
times.
It won't. That's an AF. It's a
Oh.
there's. It shouldn't spike on
Okay.
there. It should spike on there.
Oh.
Can you guys talk?
Yeah, we're talking.
You
Oh,
are a
that
lot
sounded
lower than I am.
Sounding good.
Hello?
I can speak
Is
up
there-
a little bit. Maybe I just need to talk louder. So I just mumble.
I'm just gonna turn
All
up
the
your
time.
Is
gain.
there-
How about that?
Have I maybe turned the volume down on this by sitting on it?
No, there's no volume control on there.
Okay.
Okay, we're just gonna try and go with it. I've turned you guys all the way up, and I can.
It might be worth getting like a
Huh.
secondary standard mic for the table. For
Yeah.
Like this, where you can just have everyone go in one audio.
It just doesn't sound very good when you do that. But neither does this apparently. So I'm just gonna keep turning up your gain. How about that?
Yeah.
We can try it. Yeah.
Let's see how that works.
Testing.
Hello?
I don't want to do it
Testing.
too much because then you end up with some hiss.
Right. Yeah. And that's not good either.
Are we heard?
Still no good. Wow, what the frick?
What?
All right, I'm gonna take a look here.
Just give us a second. Well, not that they can hear me, I guess. But if
Oh.
They could.
I know why.
Is there a way to do this before the show starts?
Yeah,
I'm
usually
honestly wondering.
it's
Sassy.
fine.
Very sassy, Eric. No, there's no way to
Bad
get this to work.
I know what's happening.
So it's not on our end with the mics.
So none of Interstellar was filmed in New Mexico.
Oh, you looked it up?
Alberta
Good to know.
and California.
Oh, okay.
Ah.
Sure.
Okay, so they went out of their way to find
And in
UNM.
deep space.
And in
too.
deep space,
Right.
yes, obviously.
I think there is.
You're right.
I think there is a director
Right.
who's trying to
Let me
shoot in
see.
space,
Who are you?
in actual space.
Okay. Who are you?
Tess.
Let me see.
We're testing.
Oh, what the fuck? Okay.
Yeah, that's,
I know what happened.
Technology is super cool.
Yeah, okay. Hang on one second.
Now Eric is
So-
too loud.
oh no.
It says,
Well, you
I
turned
know.
up the
hang
gain.
Hang on.
turn
one
Eric
second.
down now.
I
Turn
got
him
it.
down
All
now.
right.
Eric,
I fucking
don't-
got
No
it.
means
I'm
Just-
not
no,
there
Eric.
yet.
No means no.
I'm not
Eric,
done
just
yet.
don't talk for like the next hour. So no.
Oh my god, what in the hell happened here?
There's
Okay.
some weird quantum shit going on.
Yeah, I'm sure that's what it is.
Here's what we're gonna do. I know exactly what's happening. We're gonna take a potty break,
Two,
which
3
is
minute
gonna
potty
be
break.
really
4
just
minute potty break. Ready?
Okay.
We're
Okay,
back.
we're back. Oh my god.
Oh,
so sorry. So sorry about
Our
this.
game's back to normal, by the way?
Yes,
Okay.
I already fixed it. Okay.
We
are good.
Yeah, we should be
So sorry.
live now.
Yeah, I think we're fine now. Please let us know if for some reason it's not. But I'm pretty sure I fixed the problem. So, and I also turned Eric down. So thank you.
Someone need to do that.
Turn him down
eventually.
more. Turn him
It's
down more,
true,
please. Yeah.
Yeah. If
It sounds like it's good.
Oh, good. Okay.
Yep.
Good.
Awesome.
All right.
My
Thank you
bad.
for the confirmation.
Something happened, but we fixed it.
I'm excited.
Okay.
I'm excited.
All right. All right. So let's get back to our general intro here. So Scott, I believe you were telling us about what you do.
Oh, I do a lot of things, but I'm a chemical engineer with degrees in engineering and mathematics.
Cool.
Science enthusiast.
So you put the M in STEM. Literally.
I do, yeah.
Yeah.
Well, and the E.
Yeah, M. Like, oh.
Oh, okay, I see. I see
literally
what you
meant
did there.
EM. Yeah.
Right, and I thought you just meant M.
And then I was
E.
like, wait, what?
Yeah, yep.
Yeah. That's,
There was a moment there. That was
Yeah.
good. I liked it.
Okay,
I liked
so anyway, please
it.
continue.
What else was I saying?
What
I
do you-
like
yeah,
science.
Cool.
I like Star Wars.
Awesome.
And I got a
That's
haircut
always
last
good.
week, so that's
right.
cool.
Oh yeah, you said you
said
got a
that
haircut.
before,
Yes.
yeah.
Okay. Cool.
So
We have to know.
That's about all that's
Our
new
viewers
with me.
need to know what the latest
hair
is with
status,
your
yeah.
hair.
It's
So-
well, you can see it's a
Yeah,
little bit shorter
It's quite nice.
on all sides.
It looks good.
Front and back and
Yeah,
sides.
It's a good haircut.
Yeah.
Good marks
And
all around.
I
Cool.
like it.
So how
So
did
we're
you
good.
guys? So from the process of getting the show running, you guys are kind of self-proclaimed physics nerds.
Yeah.
I
yeah.
wouldn't proclaim it.
I mean,
I am.
Wouldn't stand in
I'm
the
a
street
physics
corner
nerd.
going,
I'm not
I'm
like
a
trying to label, but like you were both like, I really like physics.
Yeah.
So how did you guys get into physics? What experience do you have with it? Why is it important to you?
I mean, so I guess I've taken a few courses on quantum mechanics. My background is more chemistry, engineering, and mathematics, right? But
Sure.
I don't know. Ever since I graduated college, I just started reading more and more about this stuff. I don't know. I found it fascinating that there were like these are our fundamental theories about what reality is,
Yeah.
and
They
I
bring
just
up big philosophical issues.
yeah, and they have
Definitely.
so many implications for stuff like that, and so it's just fascinating to me, like the process that we went through to figure it out, and I don't know. I just feel like it's kind of my duty as a human being to know like what's going on
I
with
like
reality. You know.
If more people felt that way, I think the world would be a better place.
I hope. Yeah.
There are a lot of things that people did. The world would be
Yeah,
better
well,
for
right,
it. But
yeah. So,
yeah, I didn't take any physics classes. It's mostly, but it's a similar kind of thing. Physics is just awesome. I feel like I
It's
shouldn't
really
have to justify
amazing.
that. It is
No,
super
I'm not.
cool.
I'm
Like,
not trying
and
to
it's
have you justify
everywhere.
it. I'm just,
and,
why is it cool for you? You know,
Yeah.
like why it is awesome. Like that's self-explanatory for sure.
Yeah, because the universe is super fucking rad, and
yeah.
and like physics allows you to understand like the explosion of stars, which is as metal as it gets.
Sure.
So-
Right.
Yeah, that's totally true.
As
That is
metal as
totally
it gets,
true.
right?
Yeah.
We need a
So I just
science-
feel like the
Yeah.
most metal academic discipline is astrophysics.
Yeah, I would agree with that. I would agree with that.
Yeah. I mean, it's like, so people used to say, oh, it's not rocket science or whatever. So rocket science is one of those, I mean, whatever you want to call it. But like, I feel like astrophysics is one of those things that if you say you're an astrophysics, everyone's like, or an astrophysicist, everyone's
Yeah.
Well,
like,
especially because
Right,
all
right.
the coolest pop scientists are astrophysicists.
Totally.
They are,
Yeah.
yeah.
Right.
I mean, it's an easily like digestible topic for everyone, right? Like people,
And yet
people are
super
fascinated
deep.
by stars
and
the formation of
equally
galaxies
important
and like
for
how do
everyone
we
too,
and equally
because we're
important, yeah,
all
yeah.
in the universe together.
right.
Yeah.
You know?
Yeah.
And it directly connects like experiments that you're doing on the ground, which are kind of small and seemingly inconsequential, to really
Sure.
massive like billion-year phenomena. So
Right.
it makes like human endeavors really
Right,
epic
yeah.
somehow.
Yeah.
It's just the most epic things humans have
It
ever
is
done.
the most
so-
epic. It's true, and it's continuously epic too. It
Yeah.
doesn't stop.
Right. But we're going to talk about quantum physics,
which is like
completely nobody
There are
understands
like quantum
it.
astrophysics.
Nobody. Well, yeah. I mean, discussing like how it overlaps with astrophysics
sure.
and cosmology is
That's actually how we
fascinating. It's
discovered
amazing.
quantum physics. I don't know if you guys, I sent a video to you guys, but that's how we discovered quantum physics was through trying to understand stars. Like, so there's a stellar, there's a stellar spectrum.
Yeah.
And so they were trying to model how you could get a certain spectrum of light from a star of a given heat. And when they tried to model it using like a continuous system of physics, which they were using before, it didn't work. And so it basically said that like above a certain frequency, above a certain heat, like the frequency of light should be infinite, which was ridiculous. And so then I think it was, oh man, I forget his name. I want to say Max Planck, but I don't think it's
Maxwell.
I think it was
Maxwell.
Max
It was
Planck.
Maxwell. Okay,
Oh,
yeah.
Maxwell
Well,
was the other one.
basically, he tried to do a trick where he added like a constant to the numerator and denominator, and then he tried to gonna get mathy. He tried to integrate it to zero.
Cool.
Yeah.
He tried to set the limit at 0, and he found that it actually, when he tried to get rid of it and integrate the function, it didn't go to 0.
Yeah.
And that's how he discovered the constant. And the reason it worked was because if you only have a certain number of like energy frequencies that you can have for like a given molecule in a star, it limits the amount of energy it can put out. So that brought it from like this infinite like gamma rays to like normal visible light. And so after that, he's like, fuck, this must be what's actually going on. And so light and energy are coming in like discrete packets. And then from there, like a whole bunch of other stuff started.
So that's a great point. Like we talk about quantum physics.
Quantization.
Right. So
Well, that's where the name comes from.
Yeah, exactly. So that's a great point. Like quantum physics is called that because things are quantized when you get down to small scales, that they come in packets and discrete levels instead of a normal spectrum like we're talking about.
Which like the photon is an example of this.
Which is why things are different colors. Because when you have different molecules, they can only emit certain types of light, certain frequencies of light.
Sure,
when they're heated up.
Yeah. But I mean, that's kind of an interesting point because like quantum physics, it deals with like the very small scales of things. Like the effects are only seen on the smallest scales. It's much smaller than an atom or whatever. And so a lot of people think that quantum means small when it doesn't. It just means those discrete levels. And then my other point is that the word quantum then has been appropriated by a lot of pop science articles and marketing and marketing departments too, right? Because there's like this epidemic of people calling things quantum, like a quantum bicycle or something.
Like a quantum leap.
It's quantum leap,
which is a tiny discrete.
It's supposed to be a big one. I know it's totally wrong.
It's the opposite.
Yeah, for sure.
So quantum's been kind of used to like signify futuristic technology stuff when it's the original meaning of it.
Well, it's like back when they discovered like radium, and then everything was like radio this and radio that, and they added it to everything, and then they're like, oh, it's giving people cancer. They stopped. But
people have
but it's a similar kind of thing. It's like it's
trends
radioactive.
They made an oopsie.
An
oopsie on that one.
Human history is full of oopsies.
So how does quantum physics compare to classical physics? So we've already talked about how it's on the small scale, but how is it different or the same?
I mean, I think that's kind of what we'll talk about over the course of the episode. I mean, classical physics is kind of like the era of Newton and whatever. That Newton came up with laws about gravity. Well, not just gravity too, but like our concept of what reality is around us. Like that things are made up of little particles. That it's
very intuitive.
When we look at things, they exist. It's it lines up with human intuition.
Space is flat. You apply a force to
space is just a thing we move around in.
You're in one location at one speed.
So classical physics is extremely intuitive to the human mind because it's happens on the scale that we're used to. Right. Whereas quantum physics and general relativity are two fundamental theories of reality.
Although general relativity counts as classical, I thought.
No.
Well,
It depends on what you mean by classical, but usually it's compared with...
You can reduce, like, under certain circumstances, like, Einstein's equations to, like, Newton's.
Well, yeah, absolutely, right.
Like, it's consistent with Newtonian mechanics.
Right, so it's...
At certain
so, I mean,
scales.
the point is that Newtonian mechanics and classical physics, like, that Newton said, or planets orbit around each other, and that's described by a certain mathematics and stuff, that's not wrong. That's still correct.
Right.
But it's not accurate. It's not completely accurate.
It's a good approximation.
It's a good approximation, right? So, like, yeah, if you, under certain cases, general relativity just lines up with classical mechanics.
Yeah.
Like Newton stuff, so...
And also, one of the things I was thinking about is quantum mechanics reversible? Because that might be a distinction. So, in classical mechanics, one of the distinctions is that because processes are sort of mechanistic, you can, if you know, like the mass and velocity of things right now, you can figure out where they were, and so you can move it backwards in time as easily as you can forwards, at least in your head.
Yeah.
Or with a calculator.
Yeah, or a computer.
Or a computer.
Yeah. There's a whole like branch of mathematical computing just based on stuff like that.
Yeah.
But I don't know if you can do that with quantum mechanics because of the probabilistic
Right. So I mean,
nature.
it's and that's
so.
a good point that it's
Because I know, like, because that's one of the things is like entropy.
we're
we
getting
got
into
way too many terms.
right, so stuff like that.
I was like,
Yeah,
how
so-
deep do we want to
Right,
get?
right. Well, yeah,
Well,
we can
we
talk
will
about
get
that.
there
Yeah,
for
yeah.
sure. Yeah, we will definitely get there. All right,
Cool.
so I think that's a good intro to kind of what we're talking about. At least it's as complicated as we will get to. So, so let's move on to our first segment tonight. We're going to be doing it a little bit differently. Normally, we open the show with hypothesis testing, but we're going to have it be a short interlude in between our two main segments because we are not nearly drunk enough yet for hypothesis testing to be funny.
We're not, or to talk about quantum physics, probably.
So like
to be honest.
we're gonna get a little drunker, and then we're gonna get a little sillier with our hypotheses in the middle of the show. How about that?
Curious.
How about that?
It's almost like you're testing your own hypothesis about where the hypothesis testing should be.
I am.
Oh my God.
Doing that.
We're doing actual science.
I
on the show
know.
tonight.
I actually
That's the cool point.
You're
This
sciencing media.
I had this conversation this week while I was in a pool in Mexico.
Why
You
not?
can just
Sorry.
stop right
So
there.
literally-
I like you looked at the
That's a good
camera.
story. No, but, like,
You're just like,
literally,
be jealous.
had this conversation about where hypothesis testing should
sure.
go.
Yeah.
So, like, I am indeed testing a
Cool.
hypothesis.
All right. Well, we'll try it out.
Okay.
So what's
so,
our...
anyway. Okay, so our first segment for tonight is let's build a foundation.
Ooh,
So,
I like it.
all right, so because quantum physics is such a crazy topic, we're going to take a little time to kind of talk about a particular experiment that was essential, basically, in understanding certain aspects of quantum physics. And that is one of Thomas Young, who was a physicist. And I have a lovely photo of him.
Oh, nice.
So, yeah.
Look at that. He's a
Look at
he's a
Mr.
stunner.
Young there. Yeah,
Wow.
Look at that. I believe that's a cravat.
Oh, yeah.
his neck,
Yeah, that's
yeah.
That was a
definitely
cravat.
I feel like those are
Back
coming
when they
back.
didn't have ties.
I know,
Right.
right? No ties. But I
Honestly,
feel like
I
the
kind of
cravat should
prefer
come
cravats
back.
somehow. I feel.
I mean, look at that. He looks so badass, right?
Well, it's just so much more interesting looking. A tie is so perfunctory. I
It's
don't
true.
know.
Yeah. Like,
You don't have to pander to the guy.
a
He's
trendsetter.
long gone, Eric.
Yeah,
Come
he is
on, all right.
it's true.
Oh, your cravat, Thomas.
Yeah.
So lovely. Jesus.
All right, so Young's experiment is one of the names of this experiment, but it's also called the double slit experiment. So why don't you guys talk a little bit about how this experiment works?
Yeah,
And we have some images and we have a video we can go through. Talk a little bit about what it is.
So let me
and
give
we'll go through.
just a little historical background. So a lot of quantum mechanics and how we like developed it and discovered it came about through asking the question, what the shit is up with light.
Yeah.
All right.
It's so true.
All right.
So much
like,
weird stuff like the particle
right.
wave
I
duality
believe
and all
that's
that
exactly
stuff. Yeah.
how Thomas Young put it in his laboratory.
I think so.
What
I
the
think so.
shit
Yeah.
is up with light?
On the treatise of
Yes.
what the shit is up with light. I think that's how Rich Anthony said.
Yeah, that's exactly
Right?
how it
Yeah.
went. Yes.
Like, no, even fucking Newton was obsessed with light.
Yeah.
Like, the first physics debates were all about light.
Right.
Like, everything's
Yeah.
been about light.
So I mean, it's a good question. Like, do people? What does the average person think about when they think about like what light is? Like, it's all around us.
shiny.
Right.
It's super.
It
Yeah.
allows us to see things.
Right. We can see it.
We can see color because of it.
You can create it.
Yeah.
They used to think
Candles
light
and
came
stuff.
from your eye, not the other way
Light
around.
came from. Hey, it's a
Hey, I've seen a
hypothesis,
lot
yeah.
of shit like laser cats, like you know.
Laser cats. Yeah.
You know,
super.
But they
Yeah.
thought vision worked
Right,
backwards.
right.
Yeah, for sure.
So like so for a long time no one really knew what was going on with light. Like it was all around us, so it was easy to experiment
Yeah.
with, right? But so Newton came up with it's always Newton. He came up with this theory called the corpuscular theory of
Ooh.
light. That light came in little corpuscles or little packets
So
of
that's
stuff, which is the grossest word
It's like
ever. for
body.
instance.
So.
Oh, I
core.
didn't even think about that. Yeah.
So in French, it's core or
Right,
whatever.
yeah.
Right.
Core.
Corpus.
Yeah.
So
and
corpus.
Latin, yeah.
Corpus and Latin, yeah. So
Yeah.
it's
Yeah.
body essentially.
Right,
So it's
so-
like a
Yeah.
little tiny package. But
Right. So what he
before
said
we
is that-
continue,
oh, yeah,
hang
yeah,
on real
yeah, yeah.
quick. Hello to Lady Luthien here. I really love your
What's up?
drawings. I've watched your stream a few times, so thank you so much for watching. And also, I'm really happy that this might be your favorite thing ever. And thank you so much for the host.
I'm glad to be here.
So
yeah.
anyway,
This is great.
welcome. Yeah, I saw your name in chat and I was like, oh man, I know her. Anyway, okay,
Thanks for
so
joining
so
us, yeah.
please continue.
So as I was, so Newton had a
Corpuscles.
theory about that light came in corpuscles or little particles of light.
I know,
it's
right?
a terrible
Particles
word.
is way
It's
better.
a terrible word, right? But that's kind of like the intuitive answer to what light is, right? It comes in little packets, like we think
Yeah.
about matter comes in little packets, like
Sure.
atoms or whatever, and like matter bounces off of stuff too. So if you've got a mirror and you shine light at it, it bounces off of the mirror.
Right.
So that's exactly what you expect if you're throwing like little balls of stuff at a mirror and they're
just
bouncing
Totally.
off, right?
Yeah.
So light in that sense behaves like a particle.
Right. So so
Right.
people through Newton's time thought that light was a particle, but the experiments weren't quite lining up with that. The particle theory kind of lined up with a lot of experiments
Mm-hmm.
and behavior, but there was some stuff that was kind of weird, and so
You can get interference. I mean, that's
that's where we're
Wait
going with
for
this.
it.
That's what we're going, right?
Wait
So some
for it.
physicists, some scientists came up with what's called the wave theory of light,
Right.
right? Which is a different concept. So if you imagine like a pond of water, a perfectly still flat pond, it's flat, and if you drop something into the middle of it, it spreads out in waves, right? The water
Right.
makes waves, it spreads out. Those also bounce off of stuff, right? Like if you've ever seen waves hit a shore, they'll bounce off of it.
Right.
So that explains like bouncing off of mirrors and stuff. That explains color a little bit better because instead of having like separate red particles and blue particles,
Yeah.
now you have,
frequency.
you've got different frequencies of the waves or whatever, right? So some people came up with this theory, but nobody really quite caught on to it or believed them until Thomas Young did his famous experiment, which
Right.
is called one of the most important or famous experiments that's ever been done in all of physics.
And it's
or
been
whatever.
modified like a
Yeah.
million times to like
It has,
new
yeah, to
physics
do
has been
new
established by minor
Right,
modifications.
Right.
So, should we show it? Do we have a
Yeah.
whiteboard? I can like just draw
So,
it.
Yeah,
so
it's
I
very
have the
pretty simple,
video.
yeah.
Should
We've got the
we-
video.
Should
Go.
we just show
Um,
the video and then go through it, or
Let's show
do
the
you
video
wanna-
in a little bit
Okay.
because it spoils some stuff.
It
I
does.
Feel like.
It's true. Okay, so
So give me-
let's do
give
a
me a
general
whiteboard.
setup of this
Oh.
experiment
Okay.
first.
The,
The second one is for you to tell us things.
Oh.
yeah.
Or to, draw funny faces to make us laugh, or whatever it is,
Can people see
Okay,
this? Let's
yes.
move this over here. So the cool thing about Young's experiment is that it's so
I was gonna
easy.
draw funny faces.
It's so simple. And you can even, in fact, do this at home with a normal light or a CD. It's really easy to do with a CD or a DVD too. But what he
Dude.
did was
Really?
we
he
should
set
totally
up.
do that.
So first is the single slit experiment. So he set up a wall with a gap in it, and he put another wall behind it,
Okay.
I think people
This
can
is
see
from
that.
the
Yeah,
side.
Yep.
Generally
he-
hold it like kind of tilt it downward a little.
Tilt it downward.
Yeah.
Okay. How about there? That looks good, right?
Yeah.
Okay. So and then he shined a light through it. So I'll make like a light bulb here, right?
Yeah.
Okay. So this is the very like the
It's a
basic
really,
version of it. So this is called a single
globular light
slit.
bulb.
Yeah. Well, also they didn't have light bulbs back then,
Yeah,
so you know
sure.
it's
It was like a
it's
candle
not-
or the sun, maybe.
it's a
I don't
candle
know.
or
Right,
something
yeah.
like that, right?
This
So
was a long time ago.
so all he did was set up a wall with a little gap in it, and this gap is, I'm showing it pretty big here, but it's
It'd be-
small.
yeah, tiny.
It's got to be very tiny, right? So you shine the light through here, right? So what you would expect if light was a particle, like it's shooting little particles, right? That only the particles made through it, that made it through would reflect on the back wall here, and you'd see.
Right.
So what would you expect to see from this if
A
light was a
single
particle?
beam.
A single band, yeah. So I'll draw that just by showing like a peak like this, because we're looking from the top, right? So we'd see
The wall has a pimple.
the wall's got a little pimple or something.
Or something.
I feel like there's a better way to do this. We could just
Yeah.
shade it in or something.
I mean, okay,
Yeah,
all right.
okay, that works.
We
Yeah,
can
yeah.
try, but
It's like you're drawing
It's gonna be
like
hard to do
wave
interference with
functions
that.
on that.
Yeah,
No,
all right.
you can totally do it. You can make them darker or lighter.
Yeah, it's gonna be hard to see on the camera though, but we'll try it. We'll try it.
It's
okay.
totally-
okay.
come on.
So anyways, so this is about what you'd see. You shine it through there, and you get a little band of light on there, right? What Thomas Young did was, instead of just one slit, he put two slits in here. So I erased these and put a gap. So now we've got two slits.
Indeed, Lady Luthien, we are all adults.
We're all
Or so we
adults
think.
here. I know, right?
Although it might be debatable, I don't know.
I just
Yeah,
want-
what does adult even mean?
Yeah, that's for another episode.
if being,
It'll be called semantics.
I thought you were going to say life history there.
life history.
Also works too, but yeah.
If being an adult is not drawing light penises on a whiteboard, then I don't want
Hey,
to be
there
an
was
adult.
half the reason I erased
Then I don't
it,
want to
to
be an
honest.
adult. No, we're good. Yeah.
Hey, last episode we were talking about bacula and all kinds of shit.
Bacula, gross.
That was
Yeah, yeah.
science.
That's
So. It was science.
This is pornography.
Oh,
I
No,
don't
it's
approve.
not.
Okay.
Don't say that. We don't want Twitch to think we're making porn, okay? Don't say that. We are not making porn, I promise.
We're making porn.
Not
We're
yet.
not making porn.
Not yet.
We are
Anyways.
talking science.
Not,
We-
Which
not
is
quite
very
yet.
sexy.
We could potentially have like a critical evaluation of the effects of porn in our society, and that would be science. There's probably some science about that shit.
Or penis bones.
Or
Like
penis
we have done.
bones.
Or
Anyway,
penis bones.
okay.
Wow. Wow.
We totally did
You
a whole
guys-
thing on that.
It's true. Okay, anyway, so please continue. So we've got two slits now.
Right.
Also
So,
sounds weirdly sexual.
so the question then
You
is,
were laughing before.
Right, yeah. So the question is, what would you expect to shine on here? You guys know what,
Yeah,
you
so
get.
we're a little biased.
but I
Yeah.
think most people would say, well, you got two gaps here, so
right,
you get
so you'd
two
end
bands
up
of
two
light.
bands. Yeah, that's
Eric
the
likes
most
doing this.
obvious.
I don't know if they can see it. I like doing
There
this.
you go.
Showing two
Yeah.
bumps.
Two bands.
So you see two bands of light, right? But that's not what you see.
Right.
That's not what you see. What you see is something different, because having two gaps here teases out a difference between whether light's a particle or a wave. So what we showed here is what if it's a particle. If you've got a wave, so the light spreads out like a wave, it hits the gaps, and from each gap, each slit, we get its own wave, so it separates out. So we get two waves here, and the waves overlap with each other,
Right.
right? So this is important because the waves overlap, they interfere with each other, they
So that's,
interact
that's
with each
what
other.
Eric mentioned earlier.
Right.
It's called interference.
Yeah.
Yeah.
So, and the difference is at some places, if you've got one wave, the other wave lays right on top of it, and it makes it brighter there. It adds to it and makes it brighter. And in some
Right.
places, you've got a wave, and the other one is exactly opposite of it, in which case it cancels it out, and you've got
So
no...
you get spots of bright light and spots of no or dim light.
Spots of, yeah.
Yeah.
So,
So-
you end up, so what would it actually
So
look
what
like
you
back on
actually
that
see, and
wall?
this is why I like doing it with the thing, is because then you get this
Yeah.
pattern that looks like this. You
Yeah.
get
You've got
uh,
gaps in there where
you
you
get
don't really see anything.
a bit, this whole
It'll make more sense in
lineup.
the video. I
Yeah,
guess.
It's true.
you get a whole lineup of bands of light and dark,
Right.
and there's no way you could have that if light was a particle. right? This is explained by if the light's a wave.
A particle shouldn't be able to interfere with itself.
Right,
Exactly.
right. And
So
you
that's
couldn't
why, yeah.
get particles, it'd be super rare to have particles bouncing off and shooting all the way over the sides.
Yeah.
But this, you get
This
bright ones
regular
on the
pattern
side,
is weird if
and
it's
it
a particle.
fades out to the sides. So Thomas Young did this, and everybody's like, well, fuck.
It must be a wave. Yeah.
Light is a wave.
It
Right.
switched the entire
Light is a
field
wave, right.
until Einstein resolved
And
it.
like this is conclusive. Like there's no way around this, right? Light is a wave.
We do have an image kind
Oh,
of
cool.
showing
See,
this
oh,
a
that-
little bit.
There you go.
I like your interpretive drawing a lot better though.
Sure.
But
Even with the
this
wall
image
pimples.
at least shows the hey snaps, what's up? This image shows the sort of interference between the
Right.
waves really well. And then it has if you could lower your hair a little.
Oh yeah.
There we go. Yeah, so you can see kind of like how the color spectrum would be sort of lined up in these bands
Right.
Yeah,
on the
and it's
wall.
brightest in the middle, and then it gets
Yeah.
dimmer
And then it
as
fades
goes
out. So I mean,
Right.
this is great news. Like we did an experiment. We figured out light is a wave. Great, right?
Light is behaving like a wave.
Well, so
There's another experiment that proved it could only be a particle.
Okay, right. So that's the point
Well,
then, right?
so that's here's
So
the
that's the
thing.
point.
Like a lot of the controversy around this until quantum physics,
Yeah,
basically,
until Einstein, he got
was
his Nobel for it.
Yeah.
that like you have all these experiments that if you're looking for light to be a particle, it shows up as a particle. But if you're looking for light to be a wave, it shows up like a wave. So you
Right.
have all these different experiments that have different approaches,
Yep.
and they all have this conflicting information. And so then we have this concept of wave particle duality that kind of came out of this. Which is what is
like
shown in this video.
To Eric's point,
Yeah,
so
there
about
is-
100 years after this,
I know there's an experiment with two electrodes, I think.
you
But
might
remember,
be-
it was two charged poles, and if you shot, like, basically tried to shoot single particles of light through it, it would
Take
create,
Pale ale?
like, electricity would jump from one to the other.
Oh,
So
sure.
it was completing the
Okay.
circuit.
Right.
And one of the things about that experiment is, I think if it was a wave, it shouldn't have worked like that.
Yeah.
I can't remember the
Right.
exact reasoning behind it, but
Right.
that was one where they were like, how can it be a wave if it does this? This is what a particle would
Yeah.
do, an electromagnetic particle. And so they were like, well, wait, then what is it?
What is it? Yeah.
Yeah.
So like you were saying before, about 100 years after Thomas Young did this, Albert Einstein did an experiment on what's called the photoelectric effect.
Right.
And he won the Nobel Prize for that. He didn't win the Nobel Prize for relativity or any of that. He won
yeah.
only one Nobel Prize. And
It's
it
a
was
high
for
bar,
the
apparently.
photoelectric effect, right?
Well, because they also gave a
And
Nobel
that-
Prize, I think, for another thing related at the time, like not long before him. They like to do stuff like that. They want to see that
sure.
has an impact on the field, and like general relativity didn't have a big impact until a little bit after that. And you start
Yeah.
have satellites and all this stuff, where,
Right,
like,
right.
you see time dilation.
Right.
But yeah, his paper on the photoelectric effect showed it was another simple-ish. It's more complicated than we need to talk about here. But it was another experiment that conclusively showed that light was a particle. That if it was a wave, there was no way it could explain the behavior
Right.
that we'd see. So that was, everybody's like, what the fuck is going on now, right? Is light a particle or a wave, right? And what's really cool is around the early 1900s, we finally had the technology with which we could dim light so far that we could shoot single photons. So Einstein showed that light came in particles called photons,
Right.
right? So that's what we'll call them.
It's so funny because when I was kind of reading
Yeah.
up on this, that's not something that's normally attributed to him. At least when you first
It's
think
not.
about
It's
Einstein,
not,
you don't
yeah.
think
Yeah.
about the fact that he
Right.
basically not discovered the photon, but he identified the
Sure.
photon.
Yeah.
And he showed,
And it's so
Super influential
important.
guy.
Yeah,
Right.
like crazy
It's always
important, but
Einstein,
yet like
goddamn.
we don't even really
No.
hear about it usually.
Let
so.
somebody else discover this shit. Really, come on, Einstein. Do your relativity thing. You're good, right?
Leave some for the rest of us. Anyway.
Yeah, so
Yeah,
anyways,
so
the cool
super
thing,
important.
the reason this segs into a whole field called quantum physics is that eventually we had the technology where we could shoot single photons from a light and detect them, right?
Right.
And so we knew that there were photons because we could shoot off single ones, and then we had a wall back here that would detect them, and it would detect like where on the wall it hit.
Right.
And they always hit at a single point instead of like a spread out
Right.
thing like a wave,
I
right?
think, was it like a photochemical thing?
I don't know. They did it with electrons first, actually. It wasn't until
Okay.
a lot later.
Yeah.
They've got
But
this
it's
effect with a lot of things.
It's easier
Yeah,
to
yeah.
explain with
You
light,
can get
right?
like almost anything to act like a wave.
Sure.
But so they did this experiment and they shot just single photons at a time at the wall, right?
Yeah.
And as you would expect, since we're still shooting light, you get the same interference pattern.
Well, no, as
Right?
you would not expect.
No, you
it.
do. Well,
Well, if you're shooting single photons, this is what's
Right.
you're doing
counterintuitive about
you're
it.
doing the same experiment.
It's
as
over
Thomas Young.
many iterations because
Yeah.
you're doing a
Instead
single
of this
point,
wave of
yeah.
light
You
coming out,
right.
these
Yeah.
tiny particles, and so you expect a particle, it's one thing, it
It's
has to
one
go and
point.
hit
And
somewhere on the wall.
so you would build
And
up
over
on here.
time.
Yep. So you'd run this like a million times,
And
and
they
you'd
just-
see the pattern of the interference pattern in there.
Yeah.
Which is what you expect, because you're doing the same experiment as Thomas Young did, right?
Right.
Oh, you mean, okay, I
Yeah,
see
yeah.
You know what I'm
you're
saying? You're doing the same
Yeah.
experiment he did. You're not changing anything. You're just shooting single photons, what we understand to be photons.
Well, wait.
And then they build up in,
in this
pattern.
experiment, one at a time, though, right?
Yes.
Yes.
So then
one
you
at a
wouldn't
time.
expect it. That's my point, is the fact that
Yeah,
you get the same pattern
That's my
is the
understanding too.
counterintuitive
Is
finding.
that it shows up as
Because
a
if
single
you're shooting a
point.
single
Right,
photon, you
right.
should expect two bands.
Well, right. So this
Right.
shows that neither view is
Yeah.
completely accurate,
Right.
right?
Yeah,
Because
yeah.
the problem with this is if you're shooting single ones through here, say you just shoot a single one, it goes through either this top slit or the bottom one. And if it just goes through one slit, it has nothing else to
interact
interfere
with,
with.
Yeah.
Right?
It's just
because
itself.
the only time you get this pattern is if you've got things coming out of both gaps. So if you're just shooting one at a time, does the photon start out as a particle? And then when it gets to the gap, does it know to split into a wave? And then,
Right.
again, we're only seeing a single dot
But yeah,
on the
it
wall.
arrives as a particle.
Right.
It
together.
arrives
So
as a
does it?
particle,
So
so
does
it's
it
super
know
weird,
then?
right?
Does
Yeah.
it somehow know to come back together and get to be a
Right.
particle? So that's not good, right? Because
Yeah,
this is
that's
not a
that's
cohesive
Not very,
view
Yeah.
of the world. We don't
parsimonious.
have like a good explanation of what happened here.
And when you
So-
see one, you see it go through, and you're like, okay. But once you
Right.
do a lot of them, statistically, they make the bands one at a time.
yeah,
They make
and
the
they're
bands.
showing
So
up at all
It's like they
these
somehow
different
knew where
points,
the
so-
other ones were going to be
Right.
and would
Yeah.
clump themselves into
Yes.
these bands.
So I mean,
Yeah.
people had a great idea. So they made up these little detectors. So if I draw detectors on here, are we running out of time? Are
No,
we-
we're good.
Okay, we're good. So if they make up these detectors, which are like, imagine them like little pieces of glass, and they let the light through. So they don't change the light at all, but then they run these out to like a little box with a light on it. And these go off, the lights shine if a particle goes through the top or the bottom one, right?
Right.
So you can try
So
to
this,
figure out what's
yeah.
going
You
on.
So if it
track
goes
where
through the
they're
top
going.
one, this top detector will light up, or this one will light up if it goes through
Mm-hmm.
the bottom. So you can tell which one it goes through. So this is a great way to be like, oh, does it actually split up into a wave when it goes through the slits?
Because then both would activate.
Because then both
yeah.
would turn
Right.
up, right? Or does it just go through one? And when you do this, you find that there's two crazy findings to this. One is that you just find a particle going through one slit. So only one of these detectors goes off. And the detectors go off randomly,
Yep.
too.
Yeah.
That's a big point. It doesn't, there seems to be no way to predict which one goes off. Sometimes it goes through the top one, sometimes it goes through
I
the
assume
bottom
there's
one.
also a bunch that just bounce off the wall, too.
Right,
Yes.
yeah. But for the ones that
Yeah.
go through, it's pretty much 50-50.
Right.
And we can't really tell, we can't really predict which slit it goes through, right?
Right.
But when you do this then, instead of seeing this interference pattern back here, all of a sudden now you see the two bands. And you do this over a bunch of times, right?
Yeah, so it's like it knew you were
Okay.
measuring it. That's what it seems like, and was
Yeah.
like, okay, I'm a particle now.
Yeah, this is like not good for physics.
Yeah, it's super
People
But
weird.
the
did
act of
this-
measuring it actually changed the outcome.
Right. So like we're trying, it's almost like as if you try and investigate too closely what's going on here, it reverts back to, and this is, now we have a cohesive picture, right? The particles just goes through one slit and hits the wall. And it goes through one slit and hits the wall. We don't see any of the weird wave behavior that you get
so
normally.
strange.
So
It's crazy.
even crazier, real quick, if you get rid of both these detectors and just keep one of them,
Ah.
and say you tie the signal of this one together. So this light goes off if the
Oh.
particles go
I
through
had heard
either
of
one.
this one.
Okay.
Okay. So we'll know if light goes through the gaps, but we don't know which path it took.
Got it.
If you do this, you get the
You
interference
get it.
pattern.
Oh,
You
shit!
get the interference pattern. Right? So this is so weird. This is so weird.
Holy crap! I thought it was the interaction with the detectors. What the fuck?
I mean, but yeah, right. So it's like if you destroy some of the information about it, you get now a wave. The particles are acting like a wave again.
Magic?
What the fuck?
Yeah.
No, science.
No, science.
Any
So-
sufficiently
That's
advanced
crazy.
science
Right.
It's
is indistinguishable from magic,
insane.
even to the people who are doing the
Right.
science, apparently.
Yeah.
Magic, science is just magic that we understand a little bit better.
Yeah. So
let's be real,
yeah.
you know?
So like, what's the summary
We
of
are
all of this?
alchemists.
What the fuck?
What's the summary
That's
of
so
all of this?
crazy.
Okay, so for one thing, we've just been doing this with light, right? Because it's really easy to work with light.
You can do
But
it
we've-
so much.
The scientists actually did this with electrons first.
Right.
They've done
with
it
their
with
little-
carbon
They've done it with
molecules.
atoms. They've done
Yeah.
it with molecules.
That's so-
You can get a
crazy.
molecule to act like a wave.
The point is that
It's insane.
everything that we
Yeah.
know of, all matter, all energy,
Mm-hmm.
is like this. All energy is neither a
I wonder if
particle
there's some
nor a
wave.
wave.
circumstance you could put a human through this.
Theoretically, you could put a human through it. You could, right?
I mean, they may not be
You
attacked
might-
at the other
yeah.
end.
You
but-
might have some problems getting that through an IRB.
Right,
You know?
right, yeah.
But,
Yeah.
so we have a quick question from Lady Luthien here. Does it matter how small the gaps are or their proximity?
Yeah, it does, because when we talk about the wavelength of
Yeah.
light, it's there's different wavelengths of light. If
it's
we're
too
talking
small,
about
it gets
visible,
reflected back.
it's very
Gotcha.
small, and so for you to be able to see like an interference pattern that's like close enough together that you can distinguish it, you got to have the gaps as small as the
Right.
wavelength of the light is. So.
Mhm. And if they're too
Gotcha.
small, it wouldn't go through, and if it's too big,
You'd
you
still
wouldn't see
get
the
it, but the
interference.
light would be too faint for you to see.
Sure.
Probably
because I
the
know, like
pattern.
with microwaves, which is a form of
yeah,
light.
yeah,
The reason they have those meshes on the front of the microwave is because those holes are smaller than the wavelength of the
sure.
Oh,
yeah,
the
because
microwave,
because
yeah,
it's
right.
and so it
huge-
can't
right.
get
So there's
through.
a practical thing there.
Yeah. Interesting.
But I mean that's
I
a great
never
point.
knew that.
Microwaves and X-rays and
Infrared,
UV and that's all
heat,
all
yeah.
light.
Yeah.
So that all does the same thing.
Right.
Yeah.
And
Cool.
I guess
So
the
I guess
point is that
radio waves can like diffract around buildings and stuff. I think that's part of their way they can get places.
right, they can bounce around stuff. So
Very cool.
This is cool because once you learn about it, you understand that everything we know of is not like a little ball bouncing around somewhere.
Right.
Sometimes it acts like that, but
Well,
it's
it-
not a ball.
Well, it's
And
a wave, but it's a discrete wave, which is such a weird
Well,
concept.
but see, it's neither
Yeah.
one because
Oh,
you've
yeah.
got this weird phenomenon too, where we talked about the probability there. You've got a random. Sometimes you measure things.
That
and
may
it's
come
random
from
as to where
the emission device though, because this gets
it doesn't. No, it doesn't.
really.
Right. So that's
But
that's
wait, but
one
what
of the
about like
larger points.
Planck's constants and like below them, like there are phenomena that could be going on that you can't measure, and if you don't know, with
You're talking about
accuracy, the
hidden
initial-
hidden variable
If
stuff.
you don't know with perfect accuracy the condition of everything in the device that emits the photons,
right.
then how would you might not be able to predict which one it would go through,
Yep.
even if it's
There's a super famous experiment done called Bell's Inequality that
Yeah.
showed that is not the case. That these things are probabilistic clouds.
Yeah.
The clouds of probability.
well, no,
That you cannot reduce it down to something like a hidden
you
variable.
can, but it can't be local.
It can't be local.
Yes.
Well, it can't be local.
It has to be able to
weirder.
interact across
That's even
space
weirder, and
infinitely,
that's
yeah.
getting even more esoteric.
We'll
and
get
Yeah.
into interpretations
Yeah,
of quantum
let's-
mechanics
Right.
later. It
Let's
gets super
bring it
fucking
back in.
wonky.
Yeah. So,
Wacky.
yeah,
So
whoops,
that's
sorry.
that's sort of the gist of this experiment.
I'm glad we recorded that.
So
That interaction right there.
that was interference between two quantum beings.
The other big point on this is that just interacting with a system destroys this these quantum effects, right? So we put the detectors on there, and a lot of people have called them called the observer effect. If we observe
Yes.
this stuff, it
You're
turns
taking
back
some sort of
into a normal
measurements.
particle or
Right.
something, right? But it's more just interacting with it. Like we can't
Yeah.
look.
But
at
that's why
things.
this is weird, though.
That's
Right.
crazy
Because
because it's
if
technically
it's
so the
if it's
single,
the interaction here that
let's
matters,
show,
Yeah.
the
then you would
single
think, yeah.
observer, like you'd think this is interacting, but you're also not gaining any information.
So that's kind of the point.
So it's like-
yeah.
How in the fuck
Right.
does the individual photon know whether or not we are gaining information or not?
Right.
Like,
Yeah.
That's crazy.
And I guess the larger point is that when you shoot light into this, you can't just focus on the photons themselves. You have to focus on, because all of this other stuff is made up of matter and energy.
Yeah.
These detectors are made up of matter and energy. So you have to take all of that into account to come up with predictions for what's going to happen.
Maybe it's, well, no, it's not the detector. It's crazy.
So, yeah.
No, it makes me wonder if there's something about the like electromagnetic interaction with like transmitting the signal that somehow like decoheres it when it's 2 versus 1.
It's not something simple that there's experiments, where you can, they're called quantum eraser experiments.
Yeah.
Where you erase the information that you gained, the classical information that you gained from it.
Yeah.
And you get the wave behavior again.
That's crazy.
So
if you randomly,
So fucking crazy. Cat physics?
Schrodinger's cat experiment?
Schrodinger's cat.
No, it wasn't. It's not an experiment.
Oh,
it was.
well, it is
It's a thought
experiment.
It was a thought experiment. So when people first did this, they were like, "What the fuck are we supposed to think about this?" And so the first interpretation of these findings was that when you would basically just ignore everything that can't be detected, try to make the most minimal possible description of the world, which is the Copenhagen Interpretation, created by Niels Bohr, who basically said, okay, you know there's a photon being emitted at the end, and you know it's hitting something at the end, and in between, you don't know what's going on, but the end result is something like a wave distribution for all the photons. And so basically his interpretation was that basically all these possible sort of outcomes are existing at the same time, but they're unresolved because the photon isn't interacting with anything.
Sure.
And so all of these possible causal paths are kind of going out until it finally one of them reaches something, and then it has to, basically the universe decides whether it was this path or that path. It kind of retroactively decides what had happened.
Right.
And then you get that one point, and so you get this kind of probability wave.
Yeah.
And that the probability wave is almost what's going through the wall, the slits, and then it hits the wall at the end, and the probability wave collapses to a single point.
Right.
And the more like the probability peaks, it's more likely to end up there.
Right.
And so the thing about this is they knew mathematically there was some probability function that acted like a wave because of this, and they knew there was a particle at the end. And so it's the minimal possible description required to make sense of that, but it's really fucking weird sounding.
Yeah.
It's
Right.
crazy.
And so Schrodinger thought it was stupid sounding. So he was so he came up with the whole cat hypothesis where he was just like, wait, how does it make sense? Because it makes it's like contrary to what physics has become, which is like, don't assume that you are the most important thing in the universe, which this seemed to do. It counteracted that whole principle. And so he's like, well, wait, so from your perspective, the cat is both alive and dead. From the cat's perspective, you exist and don't exist. Like, everything in the universe is observed and, like, unobserved by everything else.
Well, but so that is it's a sort of extremified version of what this is showing us. Because what this is saying is that what this specifically is saying is that light acts as both a wave and a particle at the same time.
Mm-hmm.
And so the cat is both alive and dead inside the box at the same time.
Well,
it's different, but it is to illustrate the same sort of thing.
Quantum mechanics really is, which is you have a particle and you know where it is right now, but you don't know where it's going to be in the future, and you can't know for certain where it's going to be in the future. So all you can do is define a probability distribution across every place in the future where it could be. And according to quantum physics, that could basically be like anywhere in the universe with some non-zero probability.
So like the more accurate description of what everything is made of is it's not particles, not waves. It's a probability amplitude or a cloud of pure possibility almost.
Yes, which then gets resolved.
Which is weird because that means that before we interact with things, before we look at things, they exist in this like fuzziness. They got this fuzziness, and when you look at it, in some sense, it almost randomly chooses a new place. It randomly chooses to collapse into a different... But there's been a lot of
contention about that because people are like, how much of that probability is real and how much of it is just apparent?
Right.
So the other famous interpretation of this is many worlds, which was actually, apparently, it was created as like somebody's dissertation, and then he went on to be like a government scientist and never did anything theoretical again.
Oh my goodness.
But
popcorns.
But basically, he was like, so instead of like the universe, there being one universe that's in many states at the same time until it gets resolved at the end, you're only in one universe, and there's only one causal path, but there are an infinite number of universes, and like the proportion of universes with this outcome versus that outcome is defined by the probability distribution, the same one. So it's basically the same math, but it's interpreting it a different way, where it's saying instead of this probability wave going out and then resolving itself, it's the instant you emit that light, based on that probability, it splits into a bunch of different universes, some where the light ends up here and some where the light ends up here. And there are more universes where it ends up in the bright bands than where it ends up in the dark bands. And so...
Again.
Okay, all right. So we're getting a little technical.
We're going to reel it back here. We're going to reel it back.
Esoteric. So, that's...
But yeah, so anyway, so before we go to this video, hello, Kangaroo Beats. You have been waiting 2 weeks for our show.
So have we.
So
I've been waiting
we have been
2
waiting.
weeks.
We're so glad to be back.
I've just been sitting on my bed. I've been sitting on the side of my bed, just staring at the wall until Science Happy Hour came along.
What else are you gonna do? I mean, come on.
Well,
all right.
Okay, you got to see how drunk I was.
All right, so let's wrap up our discussion of. So Ruth Slytherin has a question. How can we tell what information is interaction and what is actually real? That's a really good question.
That's a good question.
I think this is a huge problem.
So the answer is you got to define what real means first, is the problem. That people think like, oh, are we just getting an illusion of something? Are we only getting certain information, but there's some real core to what it is?
And can it actually be observed?
And can it be observed? And the answer is there have been just genius experiments done that show that this stuff is what's real. There is nothing hidden in there that is something real that we just can't see.
We are seeing observations for a bunch of things and they're all real.
Right.
So we see observations that light is a wave, we see observations that light is a particle, and they're both correct.
Yep.
So this gets at the thing you were talking about what's his name, the difference. I was trying to
Bell's.
Basically, there was a debate. It was the whole Einstein-Bohr's debate, which is like, oh, is this just humans can't observe the things that are actually going on, so we see probabilistic stuff because it's noisy to us, but it's actually just a complex process. Versus there's genuine probability, and
there is a way you can test that. There is a just genius way you can test it.
It's a really ingenious experiment, but basically they showed that there does seem to be, basically, I think it was actually the quantum erasure experiment or something. No, that was recent. Well, anyway, but the point is, so what they've basically showed is if you want to have like a perfectly sort of deterministic universe, you have to get rid of the idea that things can only interact with other things over a certain time and distance. So, which gets to the whole idea of entanglement, which we'll probably get to later or something. But basically, you can allow for a deterministic universe, and this is the third interpretation of quantum mechanics, as long as the forces can interact instantly over an infinite amount of space.
So if I do something over here...
irrelevant of like space-time continuum.
Right. So the fact that me doing if I did something right here, it could affect something in the next galaxy over.
Yes.
Like immediately, not just
immediately.
Which
not at the speed of light, which is why Einstein.
So that's
not
completely
at the speed of light.
No, simultaneously.
Not constrained by the speed of light.
Yes. So the interaction, which is what makes it kind of weird, because one of the major underlying things of Einsteinian mechanics is that causality happens at the speed of light. We've done so much stuff that's confirmed this at the macro level. And so a couple of people kind of formulated this theory, another interpretation of quantum mechanics that's starting to become more and more popular, called pilot wave theory, with the idea that the wave and the particle both exist.
That's getting really esoteric now.
Oh,
but it's actually simpler, I feel like,
so the wave and the particle exist.
Both exist as separate things. So what happens is the wave interacts with itself instantaneously, which is how you can get these weird effects, including like if you try to detect it, the effect disappears and all that, those kinds of things. And the particle follows the wave. It's basically, its path is determined by the wave.
Yeah.
And so if you had perfect knowledge of like where the particle was and its momentum and all of those variables, you would be able to figure out where it was going to go when it hits the wall,
Sure.
but you
Yeah.
don't. And so there are some forces that are going on that you can't observe that are interacting like instantaneously across the whole experiment.
Right. That's yeah.
But
That's
the-
one.
but it-
but that's
but they're actually
that's
visible
completely contrary to the theory of relativity.
Right.
Right.
Yes.
So
which
that's
which is why they're still
Because
trying to
of
make
the,
it
the
reconcile.
speed of light constraint.
Right.
Yeah. Well, they're still
Nothing
trying to
goes-
make it reconcile with.
Well, right. So that's like a big
relativity.
the two theories. They rarely overlap,
Right.
but sometimes they do, and when they do, everything breaks down. And so we know that neither one is a complete
Is true.
description
Right.
of
You can get-
So that's why
Relativity
we're
is
looking for
consistent.
the unifying theory.
That's
of
why we're looking
physics,
for a unifying theory that will
Right.
merge
Merge
quantum
everything.
physics and relativity
No,
together.
it is unified with relativity, just not with gravity.
Relativity is gravity.
So
Yeah.
okay,
Quantum field theory.
okay,
Quantum field theory.
let's leave it.
Yeah.
I think that's a different discussion.
We can talk about relativity on a whole
afterwards.
other episode.
Let's get into this
yeah.
afterwards. I'm
Anyway.
super interested. Yeah.
All right, so we're gonna wrap up this discussion about Young's experiment with a quick video that sort of illustrates at a very
Oh,
clear
sure.
level
Yeah.
what wave-particle duality
Let's do
actually
it.
means. So let's take a look at that, and bear with me here. I've got to like get it set up, and we'll be. Okay, so yes.
I hope
what
that
the
made
fuck
everything
is
clear.
right?
I hope that made everything very
know.
clear.
Yeah.
We shouldn't need to come back to these
I
things
know.
again because it's all it's very obvious.
Bananas. So that video is showing in sort of in succession. It shows how wave would behave, or light would behave as a particle first.
Yeah, right.
And it's random, just kind of shows up as a single point, whatever. So then it shows how it would behave as a wave, and it looks a little different. And then it shows what a quantum object would be, which is technically a wave and a particle simultaneously, or whatever.
Something a little bit more, yeah.
Yeah, and then you end up with this weird interference pattern where it's a wave coming out, but then you have a particle that shows up on the end, and it shows with this sort of interference pattern over time.
Right.
And then that also shows that little eyeball thing is the observer, and how like you no longer see this interference pattern if you're actually measuring which slit it's going through. bananas. I watched that and I was like, what in the fuck?
Which does not mean a brain is required.
Right.
That's the whole thing.
So Lady Luthien just said quantum objects are self-aware and very conscious with this that's how it makes it sound. And like honestly,
no Deepak Chopra here.
Other videos that I've watched about this are saying that the photons are choosing which slit to go through,
They're
and I'm
not
like,
choosing.
no. You can't say that because it's like, I mean, it's basically anthropomorphizing.
Right.
It's making it sound like the photon has a consciousness and it's choosing it, but that's not what it is. So that's where it goes into this like probability thing where it's just probability-wise, it's going to land in these particular places more often than others.
Yeah.
And so you end up with this crazy pattern.
And then,
but
so
like,
you
the
got
big
to
question is,
kind of
what is that probability wave?
Right.
right,
Real,
like how
so,
do we
yeah.
how do we model that?
Right,
Like whatever
right.
it is. So it's
yeah.
pretty bananas.
So
But-
you kind of have to unlearn the concept that
Yeah.
things are made out of little balls of stuff. 'Cause
Right.
That's not right.
It's not how it works.
Not right.
Yeah.
And things are not made up of waves either.
Right.
Again, they
It's-
sometimes look like them, but they're this weird thing that we cannot conceptualize because our brains are not set up to do
because when you scale all of that up with like all the interactions in atoms and molecules and everything,
Right.
you don't see those phenomena. at
Yeah.
large
Right, yeah.
scale.
So I mean, this beer is a quantum object. It's ultimately,
We are quantum
in
objects.
reality,
Yeah.
it's not made up of little particles.
Right.
It's not made up of little stuff.
Well, like our
That's
computers,
actually
when we get to quantum computers,
So that's
there's
a
quantum
really
phenomenon
good
going
point,
inside
actually,
them.
because I think when people think about physics, like classical physics,
yeah.
you learn that everything's made up of particles, but yet you see solid matter
Right,
in
right,
existence.
yeah.
Like, this whiteboard we're not capable of comprehending
Right.
the individual particles. So that's actually a really good sort of demonstration of how it can be one thing
It basically
and
all gets
another thing at the
averaged
same
out.
time.
Yeah.
It's this weird
So-
thing that we can really only describe in crazy mathematics.
Right, yeah.
That's the only way we've come to be able to understand this stuff.
And so Lady Luthien just said, maybe quantum consciousness is something our consciousness can't comprehend. Who knows?
Wow.
Maybe
Too
maybe
Deepak for me.
like who fucking knows? I mean, whatever.
Too deep for me.
Yeah. It's entirely possible. I mean, I don't know.
Cool.
It's crazy.
All right,
but
well,
This is
all
why I
right.
want them to resolve pilot wave theory.
Yeah.
So that we be like, no, this is what it's like. Deterministic.
So, okay.
What
so
are we doing now,
we
Kate?
are moving on to our lovely interlude in the conversation now.
Let's get rid of this.
Hypothesis testing.
I've had too much science. Let's get on to some drinking.
Yeah. Okay, so hypothesis testing is our little interlude for this evening. And we have already been talking about science, but we are specifically going to do some science right
Science
now
the shit out of this
with
booze.
alcohol.
Boom.
And we are going to test some hypotheses about what
Let's
this
do it.
liquid is. So we have a lovely mystery liquid inside this Erlenmeyer flask. And I know what it is, so I'm going to refrain from I will drink it and partake.
That's cheating.
But I will
That's
not.
cheating.
I will not hypothesize. I will
Okay,
let you guys
okay,
do
all
the
right, all right.
hypothesizing. I promise it is edible and delicious. So
It has some kind of spice in it. I can see it.
there is some spice in it. So I'll let you guys do
I'll
some
judge whether you got too
observations.
creative
yeah,
or not.
All right, I'm gonna take
Oh,
a
you're
sip.
gonna take a sip. Go for it. Oh,
Still delicious.
she's not dead yet.
Keep on
Are
going.
you feeling any fevers? Any chills?
No, I am.
Anything
I'm
like that
totally
you're doing
fine.
good?
Could-
Yep.
Same time.
Okay.
Superposition of spice
Right.
and not
So I
spice.
hypothesize that before I taste this, it exists as a probability amplitude of different tastes, of different flavors that I could perceive, but I won't
it is
perceive until I actually
simultaneously
taste it.
disgusting and delicious
Right.
at the same
and
time.
But since you prepared it, I'm going to say there's a greater chance that it's delicious.
Yes.
And because you said it,
yes.
right?
Spice and bland.
Right?
Or
So it's
I don't
either
know.
it's
Who
either
knows?
quite spicy.
Also, some probability this is on the moon.
Right. This could be on the moon
Also
too. We're not really
possible?
sure.
It's affecting the
I guess I don't know. It's got kind of a beer coloration, I guess.
Yeah.
You know,
Sure.
it's kind of yellow.
Spice beer.
And then there's some like spices in
Yep.
it. I don't know why you do that. This seems crazy to me.
Wait for it.
Wait for it. Are they like chili flakes or something?
Might be.
Okay, I'm gonna say
Red
beer
chili?
with chili flakes, because why the hell not? I mean,
Sure.
I don't know. Oh, or are you gonna hypothesize? Should
Go
I
ahead.
drink
Go
first?
ahead,
ahead and
you
take
go.
a sip. Yeah. and then hold off
This
on
is
your
like the actual
findings.
process of science. You do
Yeah.
it, then you say
yeah.
your findings, then I replicate,
Right.
and based on what your
There you
findings,
go.
I reinterpret.
Okay.
Not a fan? I think it's delicious.
I think maybe you got too much spice there.
There's no tequila in
What? Just go. Go.
You don't know what it is.
I have no clue I still have no clue what it is after drinking it.
How is this not tequila? It smells like it. Mezcal?
Maybe.
Is that what? It's mezcal. Freaking basically the same thing. Come on.
I thought it would be masked by the other things that are in there.
Not the smell though.
Yeah. But for
Curious.
Scott,
Curious.
when I made it, I didn't know you were not a fan of tequila.
Hey,
So.
well, that's fine.
It's mezcal with spices. Maybe you also mix 2 different kinds of mezcal or something else in here, but there's definitely mezcal in here
Yeah.
and also spices.
Yes. Okay. So what this is, and I think it's delicious, is
bad.
mezcal, which is a different
growing on me.
iteration
Yeah.
of tequila. It's not tequila. Tequila is agave liqueur, essentially, that is
Okay.
made in very specific region in Mexico. I believe it's Jalisco. And basically everywhere else, so it's made in a particular region, but it's also only with blue agave. Sorry. Only
Blue
blue agave.
agave
goes into tequila.
Oh, okay, that's really
But then
specific.
mezcal is literally everything else. All of the regions,
Wow.
if they want to make it,
Your red
and
tequila,
all different kinds of
or your
agave.
red agave.
So is this
your
what
Green
you
agave, yeah.
I think
everything
they're running,
else.
they're
Your
like
plaid
farming
agave.
tequila or
Yeah.
something because it's such a specific, it's like one plant in one place.
Your
It
paisley
is
agave.
so mezcal is a lot like Mexican bourbon. It like to me it is if tequila and whiskey had a baby. So because
Whiskey-la.
yeah. So like that's actually what it tastes like to me because it's a lot smokier. Like tequila just kind of tastes like alcohol. Hey, classy bathrobe.
Disclaimer:
welcome.
Science Happy Hour does
I
not
have a less
endorse
classy
having
bathrobe.
babies with mezcal.
With mezcal. I agree.
Just-
Always drink responsibly.
Or irresponsibly, as the case may be.
Yeah.
Right.
Hey, we're legal, keeping it legal.
If you were on a science panel.
Hey, I didn't say you
know.
should
Yeah,
drink
yeah.
if they're under 21.
Hey, I have it in our disclaimer to always drink responsibly because that's
Because
how
you
it
should.
goes. Yeah.
Right.
So
That's just
anyway,
smart. That's just
so
science.
yeah. So
I don't think
this
it's actually
is
legally
mezcal.
required. I think the beer companies are just trying to scam
Well,
us.
I'm not trying to tell anybody to get alcohol poisoning so they can sue me. Okay.
Fair enough.
All right. So this is made from mezcal, which is it's kind of it's a nice mix of a tequila flavor and the smokiness. Others are very different. Every mezcal is very different, much like whiskey. But then I also added a Japanese yuzu liqueur to this.
Oh.
So
Okay,
there's
so
a
that's what you
citrusy
added.
flavor to it that is the yuzu. And then the spice
combo.
is actually tajin,
You're crazy.
which is a Mexican spice blend that is often added with salt to a rim of a drink.
Ah, but you just put it inside this time.
So I just put it in. So what this is actually it was inspired by something we had when we were in Mexico. We went to this restaurant and ordered just a little thing of mezcal, and they basically give you a shot because you're supposed to sip it.
Sure.
And they served it
Oh,
with.
now I need more. I got
Yeah, go
popped
for it. It's really good.
No.
Do you need a refill on your beverage? Would you like a refill? Can make it happen. So I think it's delicious. I don't know what you guys are talking about.
You know when you get like a popcorn kernel like stuck? to the
Oh,
back
yeah,
of your
yeah,
throat?
yeah,
You're
yeah,
just
yeah.
like, "Ugh."
And
That
it's
is super
salty
weird.
and it's just right back there. Yeah.
No, it's too far back for me to even reach.
Oh shit.
Oh wow, Eric.
I mean, I can mute you and you can go off camera.
We're gonna
That
take
was
a
a little-
break.
yeah,
for-
okay.
I'll just have to double down.
So this was inspired by something we had in Mexico where you have the mezcal just in a little cup, and then they serve it with an orange slice
Oh.
and then a little pile of that tajin. And what you're supposed to do is take a sip of the mezcal, taste it on its own, and then you take the orange slice, dip it in the tajin, and then kind of suck on the orange slice with it for a minute.
Oh, okay.
Get the flavors in there. Maybe you eat a little bit of the orange.
Sure.
It's,
You
it's,
do what
it's
you
up to
want.
you.
Yeah.
Yeah. And then you take another sip of the mezcal, and it
Oh.
kind of changes
So it's like
the
a
way it
taster
flavors.
in a
Yeah.
way.
Okay.
Yeah.
It's
Cool.
it will kind of like it's meant to enhance the flavor, not hide it. So it's not like if you're taking a shot of tequila, you're going to do like lime and salt right after or whatever. Or like however that's supposed to go. Salt, then tequila, then lime? Yeah. So, like, because that's meant to, like, mask at least shitty tequila when you're, drunk.
Is that part of
It's
the
supposed to
salt
mask the
increases the
flavor.
contrast with the sugar and
Right.
Oh, maybe.
Yeah.
it makes it taste sweeter.
Yeah.
Ah.
So it's like,
I didn't think
it's
about
supposed to be a little less cloying to
Right,
your
right.
palate if you do it that way. But this is actually supposed to enhance the flavors a little bit. So I kind of made a little concoction based on that.
Cool. Yeah.
So, anyway. Okay. So, all right. So moving on to our main event then. Let's get back to physics. All right. So, do we need a refill?
Something
Refills?
else. Just
Yeah.
Anything.
Anything,
Surprise
whatever.
Me. Surprise me.
Do you need a refill, Eric?
Sure. Booze.
Something. Some kind of liquid.
We're so pampered on this show. We're very pampered.
Our studio audience is very
The height of
loyal.
life.
Yeah, I was thinking,
Yeah.
what show has a studio audience that gets them things?
I know, it's
right,
true.
right.
And gets them booze, no less.
It gets them booze, yeah.
So
I feel like a lot of the local news would be improved. If...
There are many things that are quite boring that would be improved by
Yeah.
drunkenness.
Sure.
Right.
Responsible
I
drunkenness.
know.
Thanks,
yeah.
Eric.
Responsible drunkenness. So okay,
Cool.
so the Young's experiment was sort of meant to get us a little bit of a foundation into quantum mechanics in general. That experiment makes a lot of these other things not necessarily possible, but we have an understanding of why it works.
A little bit, yeah.
Because of it.
Yep.
Somewhat. So for our main event tonight, we're going to be talking about quantum computing.
Quantum computing, cool.
So
Two
this
great things that
is-
go great
Neat.
together.
Yeah.
Yeah.
This is something that's still an emerging field. We don't yet have a quantum computer, although Intel says that we are very close.
No,
We have quantum
okay,
computers.
wait,
We've
wait,
got.
wait.
We got.
We have-
okay.
we
We've had them
have-
for
Sorry.
years.
We
They just don't
have,
do
like,
anything interesting.
Quantum computers with like very small numbers of quantum bits.
yeah.
But you
right?
only need a small number to be equivalent to a standard for certain operations.
Yeah.
For certain
Yeah.
operations,
Okay.
yeah. So,
Okay.
but like,
Okay.
Yes.
Okay.
Yeah,
Anyway,
yeah,
sorry.
yeah, we're
I'm completely aware of how this
Okay,
works.
yeah, right.
So,
A wild beer appears.
Gracias.
ooh, is that a
Quick,
Pokemon
capture it.
reference?
I think it was.
Cheers.
Wild beer appeared.
Cheers, Eric. I gotta get one from over here. Okay.
Cool. All right. So
All right.
how are we gonna
So-
start into this?
Yeah, so quantum computing is still an emerging field. This is something that is actively being worked on right now. And the whole point of a quantum computer is that it's meant to be something that's more powerful than our standard computers, laptops,
For certain
whatever it
operations.
is. For certain operations,
Yes.
yes. There are some things that
It's
a
a-
standard
it's a big
computer
point, though.
will always be fine for.
Yeah.
But like the whole point of a quantum computer is that there are certain things, certain operations that we would want to do with data that can be made much faster, much more efficient using a different process.
Well, it's
Basically.
I have a really quick example if you want me to do
Great.
it
Let's do
for
it.
like what it goes
Yes.
on. Where's that whiteboard again?
Whiteboard, where'd
Here
it
it is.
go?
I got it. I got
Okay,
it.
Cool.
Okay. So
Let's do
quick.
more drawing.
Okay. So let's.
Draw it.
Yeah.
Like,
no.
yeah, there
I'm
you
thinking
go.
about how to start it. So let's.
Parallel operations, basically.
Here's my example.
Well,
Let's say.
okay, go ahead.
Let's say Eric is a bouncer at a club. Okay.
Okay.
You've done it before. You know. You
Yeah,
used
okay,
to moonlight. You used to moonlight
Let's
as a
set
bouncer.
the
right?
scene. You've got
Set the scene.
an hour-long line at a nightclub.
Hour-long line at a nightclub.
I think I see where
on
you're
a
going with.
on a
yeah.
Thursday night.
Thursday night, and
I'm
you're
so
like,
not bouncer material.
I'm like, I'm standing in the line. I'm like, fucking A. I've
Right.
been in this line forever.
Oh my God.
I don't know if I'm gonna get in.
Right.
Like,
Very exclusive club.
Yeah, very
you know,
exclusive
Eric's
club.
been working for years
Are we
to
going
get a
club?
job
Yeah,
here
yeah.
at this, right?
yeah,
Okay.
you get to carry a gun. Like, I don't know.
So Eric, you get to
Are
carry.
you explaining like
I'm just let me
transistors
get
now
into it.
via
No,
bouncers?
it's a really easy. Okay, so Eric's a bouncer at a club, right?
Yeah.
And people come up to him, and they try and get into the club, and Eric either turns them away or lets them in, right?
Right.
Okay, so let's say...
What are your characteristics you're looking for? How are you?
I swear, I feel like you're explaining transistors via bouncing. Like,
Nope, just watch.
Like,
Okay,
is it dress code?
So
like,
let's
why
say-
do you turn people away?
let's say 8 people come up to
Not enough
Eric
chicks.
in the line.
Yeah.
That's
I
the
mean,
usual
that's,
rule,
that
isn't
is
it?
usually what it is, yeah.
Physics club.
Yeah, not enough physicists.
1, 1, 1. Okay, so let's say 8 people
There you
come
go.
up, and we're going to represent them by 8 numbers here,
this
okay?
way.
8 binary numbers.
Now I have no
see
idea.
that?
You can hold it down, just tilt it.
Oh, yeah, just tilt it. Oh, cool. So these are the people that are coming up to Eric to try and get into the club. So they trying to get in, and then Eric either lets them in or turns them away, right? And if
Oh,
he
I
lets them
negate?
in,
Okay.
and if he lets them in, then they get a 1. And if he turns them
Okay,
away, they get a
negate.
0. Okay?
I'm a logic gate.
So this is comparable to how like our computers work today, right? Our phones and our laptops, they've got all these little switches in them that are either zeros or ones.
Well, yeah,
Alright.
basically.
Yeah, right? Just right?
All right.
Go with it.
Right, Eric?
This
We'll
just
get
glided
into
over so many things.
It's
Doesn't
an
matter.
example.
Doesn't matter. It's a
an
basic example.
We'll get
Okay,
there.
so the point is, so Eric acts on each of these people and either lets them in 1 or turns them away 0, right? And Eric follows one of 2 rules. Either Eric is feeling super good that night
Yeah.
and he lets everybody into the club.
Ah.
Okay? And he just lets people in, whatever, right?
Everyone gets a
everybody
car.
gets to go into the club. Easy, right? Or his like boss is on him, he's feeling more like workaholic or something.
Exclusive,
More
yeah.
exclusive, that's a good word for it. More exclusive, and he only lets half of the people into the club. Okay, so half he lets in, half he turns away, all right?
Got it.
So either, with all of these people, either all of them are let in and they're all 1s, right? 1, 1,
Okay.
1, 1, 1, 1, 1.
Right.
Or Eric only lets in half of them,
Okay.
in which case it could be, I don't know, it could be 0, 0, 1, 1, 0, 1, 0, 1, right? 4
Okay.
zeros and 4 ones. Okay.
Mhm.
So we know that Eric follows one of those 2 rules, all right? So if we're running a normal computer, our laptops, our smartphones, and whatever, what the computer does is it goes through each number. It does this number, and then it spits out a 1 or a 0.
Yeah, definite.
Okay?
Yeah.
So the question is, what's the...
Iterative.
Right.
Iterative.
Iterative.
One step at a time.
Iteratively, yeah.
Iteratively.
So the question is, like, in this example, what's the minimum number of people that have to come up to Eric for us to determine which rule he's using?
Right.
What's the answer to that? What's the minimum number of people that have to come up
2?
to determine whether
Yeah,
you're letting
2.
everybody in or nobody
2.
in?
2.
2?
Yeah, 2. And I feel like this is going
It's
way...
1. It's 1.
Wait, but how can you determine
Oh,
half?
it's
one.
1 because
Because
if the first one is a 0,
If the
then
first
you know
one
it's
is
got to
a
be
0,
at least half. Yeah.
right? Then
Okay.
he's
Right,
following
right,
the
right.
half rule,
Yeah,
right?
Yeah.
So that would be the minimum. You gotta check it once, and if it comes up 0, you're like, boom, Eric's only
We
letting
know
in
the
half the
rule
people,
now,
in,
right.
right? Okay. So the other question is, what's the maximum number of people that have to come up?
2.
Nope.
No?
Nope.
Okay.
Because 2, I could go 1, 1.
Oh, right. Okay. Yeah.
Is it also
Okay.
1?
Does this tell us which rule you're following? You let 2
Yeah.
people in.
It's
So
it's
what's the
whatever
maximum
the
number?
number is that your first 0.
So right. So when
Okay,
would we
so you'd have to get 4.
right, so you'd have to have
Okay,
4
yeah.
ones.
And then if you had just 4 zeros. Okay.
So
that
you
makes
need
sense.
5 people. That's
Got
the
it.
answer. You need half
Okay,
plus 1.
Right,
Okay.
that makes sense.
Does that make sense? Like they would need minimum.
I'm trying to figure out where you're going with this.
Just watch. Just watch.
Wait for it.
Okay, so minimum 1, maximum 5 people.
Yes.
And this
Okay.
is how normal computers work. They go through, bam, and then you get out a 1 or a 0.
Yep.
Oh,
Bam,
this
you
is
get
a
out
search
one of the
procedure.
It's a search
Okay.
procedure, right?
Okay, now I see what you're
Okay,
doing.
all right.
Are
yeah.
we dumbing
could've
it
just
down
said
to for you, Eric?
Sorry, Eric.
No, but
It's
I mean,
only an hour and a half show. Come on.
no, but I mean,
So for a normal computer to figure out which rule Eric is using, it's got to
I
go
just feel
through.
like this is
It
too
could go through
complicated.
at
That's
most
why.
5 people, right?
Yeah.
Okay. So now a quantum computer is different because, as we learned with Young's experiment, we can make these switches, instead of having a 0 or 1 exclusively, they're in a
Multiple
superposition.
states at the same
They're in
time.
this
Right.
fuzzy probability cloud of being
Yes.
either a 0 or
Or
1.
1.
Okay?
Yeah.
So if we change all of these to a 0 or 1, right? There are ways in which to work a quantum computer with this number of bits such that it will tell you whether Eric is letting everybody in or only half.
Right.
Yep. It basically
and it's
searches.
evaluating all
yeah.
of that.
At
It
the same
evaluates
time.
it all at the same
and
time.
then gives you a single answer.
and then
So,
gives you a single answer, right?
for a practical example that's similar to this, if you were searching like a database in
Right.
like a company, or for YouTube videos or something like that, or Google,
Yeah.
it could search it could basically do all the searches simultaneously up to, it depends on the number
Right.
of quantum bits it has.
Yeah.
Right.
And then it will do all the operations at the same time according to some probability distribution, and then
Right.
spit out one answer. And given that the answer is probabilistic too, you have to do it a couple of times to make sure.
Yes.
Right. So
But
the
then,
point.
but
yeah.
that's so much faster than doing it one at a time.
Right. So
Yeah,
the point
so much
is you only
faster.
need one step with a quantum computer. Just one step instead of 5 before, like we needed
Right.
5 at most.
Yes.
The quantum computer just does one step and it tells us which rule Eric's following. It doesn't tell us each individual person though.
Right.
That's
So
what
it
a
depends
class.
on what
It doesn't tell
you're
us
you
trying to
whether
can't
each
figure out.
examine what's-
person
yeah.
is 0 or 1.
You
with
can't
it.
examine what's going on in the computer because that would be like the switches we were talking about that destroyed the
Right.
interference pattern.
Right.
Yeah.
It was called decoherence.
Right.
So
So
you
instead,
basically, it's this
yeah.
black box. You know how the box works, but you don't know what it's doing at this time. And you can only observe it at the end when it gives you the result. And if you observe it before then, you destroy the whole process.
Yeah.
Which is part of the reason why they're super expensive, because you have to keep them like super cold and
Super
isolated
contained,
from
yep.
outside
Yeah.
influences.
So the point is you can do certain things with them
Much
in just one
faster.
step, or just super
Right.
a lot faster than you would with a regular computer. But you don't get all of the information that you would get from a regular computer
Yeah.
either.
And there are also
You can
some
follow out general
algorithms.
stuff. So.
There's some algorithms that
Yep.
have to be one step after another,
Right.
and if you did it like that, it would actually be slower because it's a more
Right.
complicated
Yeah,
process,
yeah.
and then you have
Yep.
to do it like a couple of
Right.
times.
So only
So.
certain things benefit
yeah.
from
So
this,
anything that can
right.
be done in parallel is basically like the world's most powerful parallel computer.
Right.
Right.
No.
So are any of you guys wanting a potty break?
I'm good.
I'm good.
Yeah, I'm good.
Okay.
Do you need?
I need a potty break.
Let's take a potty
All right,
break.
you should have
Let's
said
take a
that at
potty
the
break.
beginning. So tried to push it off on us.
I'm trying to keep it, so that we all go at the same time.
Yeah.
But okay. All right. So that was a really fantastic example.
Okay, great.
Let's go
Yep.
pee now, and we'll be
Let's
right back.
digest
Let's.
that. Digest it.
AKA, I'll be right back because I have to pee.
All right, we'll see
Okay.
you in a few.
All right. keep on
Yeah, okay.
going. Yeah. Okay,
Yeah.
we're back.
Hey.
Yay! My
What's
bladder's empty now. Yay! Okay.
It's in a superposition of empty and not
Yeah.
empty.
I know. Oh my god. Okay, so I just wanted to call out to everyone in chat at the moment because there's a lovely conversation here. So I don't know what they were doing while we were on a break. So they might have been downing shots of tequila. I'm not really sure, but I was actually peeing.
No.
So.
No.
I
would not do that.
But Kangaroo
Gross.
Beats also is in the west coast of Australia, and said that Inertia TV is how he or she starts his or her Saturday morning.
Oh, nice.
I love that.
Cool.
That's awesome. Thank you so much.
Yeah.
We're so glad to have you.
Yeah.
Cool. So anyway, awesome. Welcome from Australia. Way the fuck over there.
Nice.
That's so cool. All right. So.
I love Australia.
Foraging for desserts, super important.
I've never been there.
Just
but-
Yeah.
any reason?
My
Scott
concept of
here-
Australia is
Scott
really
here
nice.
made
There's a lot of
key
things that
lime
can kill you.
Key lime pie.
Wait.
Key lime pie.
Key lime pie.
Yeah, that sounds like the Japanese version of it or something. Okay, all right.
Was
Yeah.
that you trying to do an Australian accent?
something
What was
made,
going
yeah.
on?
Anyway,
I liked
so
it.
Scott made key lime pie.
I did make key
for
lime
Scott
us,
made
pie.
key
so,
lime
so we
pie.
will also have some desserts later. But anyway, okay.
Nice.
I guess I'm a little drunk.
My nerd bone
As
is
it should
tingling.
be.
Yeah.
Oh, great.
Responsibly
Glad-
My bone
drunk.
is tingling.
I'm glad people are liking it. I'm glad people are.
Yeah, I don't have to drive anywhere after. So.
Yep.
Yeah. Okay. So cool. I'm glad you guys are liking it,
Yeah,
and
awesome.
yeah, the nerd bone is a very important bone to tingle. So we're very glad that we are stimulating
Not a
Important
it
sexual
for you.
bone. Nowhere
Not-
near
It's
it.
in your brain.
Yeah.
Yeah, it's in your brain. Totally.
It
Probably
can
get that
be-
looked at.
It
if you have
can
a
be.
bone in your brain.
It can be a lower bone. But don't limit yourself.
Yeah.
It's a bone that covers the whole body.
Okay, yeah, right.
All right. Okay. Let's bring it back. Okay. So we're talking about quantum computing. We gave this really great example of kind of why it matters. I guess that's showing how it's faster and more efficient for
Yeah.
certain things.
Which includes stuff like breaking encryption.
Yes, so that's one of the biggest examples that people use.
Yeah,
of
And why it's
we'll get
potentially
into that.
dangerous,
We'll get into
actually.
Right,
yeah.
totally, absolutely. Yeah.
Because So I don't know if you want me to.
Well, so I'm going to show this video. So
Okay.
so tonight, let me show the little thing that we're
I like
talking
videos.
about here.
Don't
so
we all?
so
like
we're
movies.
talking about this infographic that just came out in Nature Outline, which is it's basically an infographic, but it's meant to be like a scientific sort of meandering on quantum computing.
A treatise.
A treatise, if you
Yeah.
will, yeah. And so this is kind of what we're talking about, and they made a video about this infographic that kind of explains the whole thing. So I'm going to show this video, and then we'll talk about it.
Let's watch.
So,
Cool.
So let's watch.
Quantum computers could one day solve some of the world's toughest problems. And they'd do this by working completely differently to a regular computer. Information is stored in your laptop in bits. Every bit is either a 1 or a 0, up or down. But quantum computers are made of qubits. Unlike bits, qubits can be a mixture of 1 and 0 at the same time. Quantum computers are made of several entangled qubits, with all their states connected together. But actually building a quantum computer is a challenge. In normal computers, it's easy to add more bits. But for quantum computers, the more qubits you have, the harder it is to add one more. This makes it tricky to scale up from a simple quantum computer to something more powerful. Another problem is that quantum computers have to keep their qubits protected. Too much interference from the outside world, and the entanglement is broken. But overcoming these challenges and building a powerful quantum computer would come with big rewards. Take searching. Imagine you have a bunch of mixed up business cards. How would a computer find the right one? A normal computer has to look through one by one until it eventually finds the right card. But a quantum computer has a trick up its sleeve. Because the quantum computer is in many states at once, it can search all the cards at once. After several sweeps, it finds the card. And quantum computers could help tackle all sorts of other problems, like modeling protein folding and cracking data encryption. But even if scientists can one day build a powerful quantum computer, it probably wouldn't be useful for everyday tasks. So don't throw away your laptop just yet.
So that's the gist of it. And also, I totally agree. Those quantum
My
bits
one
look
was
so delicious. They look like little balls of cotton candy. I
wanna
totally
eat
agree with
them.
you. Yeah.
So
I want to eat them.
a bit is a single piece of information, which in the
So hang on. So
Okay.
we have this question from Lady Luthien, who is asking what exactly is a bit made out of, and what is a quantum bit compared to that?
yes.
Do you want to take that? Go
yes.
for it.
So a bit in mathematics is a single piece of information, and so in a computer, it's basically a single switch. It's the 1 and 0. Is it on or
Right.
is it off? In a quantum computer, it's a bit stranger because you have all of these. Basically, the quantum bit is an electron, and electrons are slightly magnetic. They have a north and a south pole, just like other things. Even though we think of them as being negative, they're slightly more negative on one side.
Right.
And so, they can be aligned with the magnetic field, which is their down state, which is basically like when the compass needle points north, or if they're perfectly flipped to go against the magnetic current, they're in the up state, which takes slightly more energy. And so you can think of that as being the 1 as opposed to the 0.
Gotcha.
And the advantage of this is an electron spin, its up or its down state, is defined by quantum properties. So it can be in both kind of simultaneously defined by some probability. And you can have a bunch of electrons that are like this, and they're all entangled, so they're all interacting with each other
Right.
and related to each other, interacting seemingly instantaneously, and their positions are all sort of undefined. They're defined by probabilities. And so in this case, the probabilities are the bits.
Right.
And so instead of just having something simple like it's up or it's down, you have some probability that these electrons are up and these are down, and versus some probability that these are up and these are down.
Right.
And so that actually allows you to store more information in the same number of switches, basically, because the electrons
Right.
are switches in this case, than if you were in a standard computer. Standard computer would just be, is it on or is it off? But in this case, it's this whole complicated
It's weird,
function of
fuzzy,
all of them.
weird
And
fuzziness.
actually,
And
Yeah.
the blue and pink of
Yeah.
those little balls that looks like cotton candy, they all had sort of different shapes of the pink and blue, and that's supposed to represent those different probabilities.
yes, exactly. And so, oh man, I'm starting to get pretty drunk now.
I'm doing my job correctly then.
But
So through some really complicated engineering and
yeah,
mathematics,
there's some great
we
like
can
if
leverage
you
that.
check out
Right.
Veritasium, their which is a YouTube channel.
Yep.
He talks to I think like a Portuguese or a Spanish guy who's making a quantum computer, and he explains really, really well how it actually works. But yeah, so basically the advantage of this is for if you have 4 switches in a computer, you have 4 bits of information.
Right.
But in a quantum computer, because they're all sort of entangled and they have all these probabilities for each of the states, you actually get exponentially more bits of information in those.
Right.
So you could have 4 qubits, quantum bits, which is basically 4 entangled electrons, and they translate into, I think, 8 standard bits. So basically for every 4...
16.
16?
2 to the 4.
Oh yeah, you're right.
Yeah.
2 to the 4. And so if you had even just like, I'm trying to think of what the number would be to exceed what we currently have for computers. Basically with a small fraction of the number of quantum switches that you have for a normal computer, you could actually have more power than any current computer has for parallel operations.
The caveat is that you can only do very specific types of searches or computations.
It's the entanglement that makes this happen, and the whole
Right.
thing about the entanglement is that they're kind of in multiple states at the same time, so that it's only useful if you're doing multiple operations at the same time, like searching through a whole database where you're searching everything. If you need to do one thing at a time, the entanglement doesn't matter, and they're basically operating like a normal computer, except they're not designed to operate like that, so it's a much slower process. So if we had like really cheap, small quantum processors that could work at room temperature or something, and you put them in your computer, they would probably coexist with a standard processor.
Yeah.
And so you might have quantum graphics cards, for example.
Yeah.
But
That would make for some really interesting gaming, probably.
yes. But one of the things this can do is, so for online security right now, a lot of the most secure operations are done using public keys, which is the best way I've heard of this explained is, imagine you have a briefcase and you put a lock on it, and only you have the key. And then you mail it to the person you want to have stuff inside the briefcase, and they put their own lock on it, and they keep their key. And then they send it back to you, and you unlock yours,
Okay.
and you send it back. And so now it only has their lock on it.
Right.
And you send it back to them, and they can unlock it. And so when you're doing stuff like financial transactions, and like when banks are doing transactions like this, this is what they have. They each have their own key, but they can send the file and their key with it to the other person, and someone watching can't decrypt the information and steal your bank account information, for example. And this is basically protected by the fact that in order to kind of decode this without knowing what all the keys are, you would have to try out tons and tons and tons of different numbers, and it would take you longer than a human being can live. So
wow.
In many cases longer than like the age of the universe.
yeah,
with our
basically like
current
the heat
computers.
death of the universe would happen
Right.
before you could unlock this
Right.
file.
So I mean, it's
So-
possible.
That's
Like
crazy.
it's possible for like somebody to sit down and throw their computer on cracking the
Yes.
key and to come up with it on the first time.
Yes,
Right?
but it's
possible.
very unlikely.
But
Right.
there's so many
Because-
possibilities. Yeah.
So
right?
for anyone who is a little mathy, it's basically factoring a polynomial.
right.
Yeah.
You each have one half of the polynomial.
Yeah.
And so it's an equation, basically.
And so a normal computer, like we were talking about before, it has to check every single number
so
and
for
go
a
through
quantum
until
computer,
it finds it.
it can check many possibilities simultaneously. And as
Right.
you get really large, powerful quantum computers with many quantum bits, you could check an enormous number of keys at the same time. And like basically, you just run the computer a couple of times, and you found the answer.
Right.
Yeah.
And
Which is scary.
Yes.
I mean, if
Yeah.
that's
which it basically means, because so far, basically the whole basis of encryption is nothing is perfectly secure in infinite time. You
Right.
get in enough time, you can eventually find out the
Sure.
answer
Right.
to any encryption. It's just based on the fact that like no one would be able to find it any time that mattered.
Right.
Right.
And quantum computers destroy that.
Yeah.
And we don't have any algorithms that are so strong that a quantum computer couldn't break it right now. So it
Yeah.
would basically mean nothing potentially would be secure.
With the current stuff that we use.
Yes.
right.
Yep.
But everyone would have to have the same technology in order to be
Yes.
able to break
Right.
those things.
Well,
So
the thing
that's
is,
another
with
point,
government
like,
espionage
to-
and stuff like that, as long as a government has it, the government
Right.
could decrypt the files.
Which honestly, like when I think about that, to me that it feels like we'll probably enter into sort of an arms race like we do with nuclear weapons, but with quantum computing technology.
Sure,
Like
right.
that's a totally
well, people are
reasonable
predicting that
thing,
with
yeah.
artificial intelligence too.
Absolutely,
and,
right.
Basically,
yeah.
computing technology is becoming the most important thing
For
for
sure.
human beings right now, including for the conducting of warfare, where now we're like hacking each
Yeah.
other instead of invading each other.
I know, it's totally
So-
different. Yeah, it's
So
crazy.
stuff like
Yeah.
big advances like quantum computing totally change the game.
Right.
And they can change who you can spy on and who you can
Right.
mess with. And,
We're still a ways off from that.
Yes,
so
we are,
is the
yeah.
They're
point.
still
So,
big
so
and
what do
expensive
we,
and
what do we
weak.
have right now?
I think the biggest like complete quantum computer that we've built, functioning quantum computer, has 20 bits to it. I think
Okay.
they're testing it right now.
20 quantum bits.
20
right?
quantum
Yeah.
bits.
Which is
20 bits.
2 to the 20 standard
Yeah,
bits.
but,
which is a crap ton.
Right.
Yeah, but it still can't factor that many numbers.
Well, part of the problem
Yeah,
also
like
really-
what,
we don't
what
have, like, a
number,
good-
what number of quantum bits is necessary
Right,
to
so
do
so
some
that's a
of
good
these
question.
things?
So like within the short term, our encryption uses about 4,000 bit
Okay.
encryption. So if we would need a 4,000 bit quantum computer to be able to break that stuff.
Got it. Quickly, anyway.
Yeah,
right.
right. To be able to do it quickly or
If
whatever.
you
So
if you
we're-
had like 100 quantum bit, would you do it? You'd still do it faster
No,
than.
No, I
would
think
it still
no,
be
I
an
think
infinite
you
level
would,
of-
You really still need a 4,000
Okay.
level quantum computer for
For
you
it
to
to
be
be
able to.
Because this is the whole thing with like exponential things.
Well,
Yeah,
it's
totally,
exponential,
right.
but it's not because you need a different quantum bit for every single classical bit that you have
Yeah.
to crack encryption
Yeah.
level
Right.
stuff. That's
Yeah.
what I'm saying. So
Yeah,
we
but
would
her
still
point
need
is you could try a set of answers,
Right.
and then they fail,
Like,
and then you
is-
try another
is
set.
An
Maybe.
intermediate quantum computer better in that scenario than just a classical
Maybe,
computer?
maybe,
You know,
yeah.
like is it
I think,
even
yeah.
is it even
We
helpful
haven't,
at all? You
we
know
haven't
what I
even
mean?
programmed them well though, because the thing is they're so new. We don't
Right.
really have like operating systems for them or like
Sure,
UI
of course not.
or
Right,
anything
yeah,
like
yeah,
that.
yeah.
And so there may come a day when like the standard corporation uses quantum processors for
Yeah.
database management, but we're nowhere near that stage. Even if we had the technology,
Right.
we don't have any of the stuff to run it to make it user friendly
Totally.
and understandable.
I mean, it's certainly
And it has whole different algorithms.
Right.
so-
Even when it's fully matured, it's still only going to be at least initially in the hands of particular bodies.
Big
you know,
governments or
it's
big
not going to
companies.
be
yeah,
right.
or universities.
Or
yeah.
universities. Like it's not going to be like the personal computer level
Right.
kind of
Although
stuff.
eventually it may
right?
get there.
I mean,
Which is
I'm
similar
not-
to
I'm
the
not sure-
trajectory of computers in general.
Yeah.
I'm not sure it would trickle down like
I
regular
don't
computers
know
would
if it'll
have
be
to
necessary.
normal.
Right.
Right, because
But
it's only
our
for
computers
specific
do
things.
parallel things, though. They still need to do
They
parallel
do, but
things.
like in the future, I could see like Google develops their quantum computer, and then they
Yes.
let people connect to it
And
and,
it just
run on
works.
it.
So this gets to the
Right.
issue
You-
of
I
how
don't-
good the internet gets. But
Well,
it still
sure.
might be, if it gets cheap enough, like I said, it still might be useful to have like quantum processing in your graphics card, for example, or for
Right.
certain math
Maybe it-
operations.
Maybe,
Maybe
yeah.
it makes
well,
the whole
yeah,
process
maybe,
more
yeah.
effective, but
'Cause
like on a daily
but
basis,
Our computers try to do parallel things all the time.
I just can't imagine on a daily basis a single individual, like a normal human
Right.
being, needing this kind of thing. Like if I'm gonna search through my business cards, like
Oh, yeah.
I can wait a
right.
few seconds. Like
Right.
I don't need it to be.
Yeah.
I mean.
Although once you get that, you get super
I know,
impatient.
it's true. I was gonna say, like, once you get the lightning speed, you never want anything else.
Right,
But
yeah.
like,
You're like, oh, 5 seconds.
right.
Yeah, exactly.
So
yeah.
it's kind of a slippery
Yeah.
slope, I guess. But
Right.
we do have a couple of questions.
Yeah.
So I guess it's not a question, but Kangaroo Beat said information is more power than weapons these days, and that's
Because
totally
the weapons
a
are
good point.
guided by the information.
I know, yeah, I think that's really true.
Yeah, right.
But also, like, regardless of weapons, information is like intelligence, whatever you want to call it,
that's
is
this
super,
question,
super
too.
important.
Yeah.
And back a little bit ago, Kangaroo Beats asked, would quantum computers need to be organic as well?
Organic.
So that's
the
a
real
separate
question.
thing.
Well, I mean,
There are like DNA.
well, but
people
but
trying to do
hold on.
DNA
So like
computers and
just the quick answer is that when you say organic, you mean things that have like organic molecules in them, right? With carbon and stuff like that.
He could mean
The answer is it doesn't matter.
pesticide-free.
The answer is it
produce. I
doesn't
don't
matter.
know.
And,
And
they
that
think
was-
that's actually how some birds navigate. Is
Oh,
their
no way.
quantum processes in their eyeballs that
Yeah.
cause Basically, no, it's entanglement.
Yeah.
It's entanglement. Like
You're
they're
crazy,
The world
Eric.
is
You're
so
crazy.
There are photoreceptors in their eyes their light hits the back of your eye and it causes a chemical to react and that causes an electric reaction. And these birds have chemicals that create entangled particles and they shift based on the polarity of the Earth's magnetic field. And it allows them to kind of see the magnetic field of the planet, which is fucking amazing.
That is crazy.
Yeah.
What the fuck?
Evolution, man.
That is so crazy. I love that shit.
I mean,
this is why science is cool. Oh my god.
The larger point is you can make a quantum computer out of anything because this beer is a quantum object.
Yeah, like that's.
This pen is
Although,
a quantum object.
Like,
you have to isolate
it. We are quantum
objects.
objects.
You have to isolate it
Yeah.
It's super complicated to turn me into a quantum bit.
Yeah.
Because I'm made up of a trillion.
You have to
trillion
take you
molecules.
close to
atoms.
absolute
Yeah,
zero.
Right. You gotta freeze me down.
Yeah.
I would try it. I would try it once. Don't
knock it.
Don't knock it until you try it.
Yeah.
But the point is, you can make a quantum computer with anything.
With
if you
anything.
wanted to.
That's
yeah.
insane.
Right.
Avocado toast?
Just
So-
some things are harder than others. Yeah.
So now,
else
Classy,
we got?
we're going back a little bit. We've got a few really good comments here. So, Classy Bathrobe is asking, what would a quantum computer be capable of in 50 years?
50 years.
So, I just want to call attention to the 50-year mark on this
let's
because
talk about
the amount of shit that's going to happen in
You haven't
50
seen this happen in the
years.
past 50 years.
that. Yeah, right.
So this gets on to a whole other topic that we will have another episode on, and I really want to talk about this because I talk about it all the time. Is like the singularity and the idea.
Oh boy.
I'm not going to get into it, but like the
Oh,
idea
no.
that technology is advancing at an exponential rate, that like the amount that we've seen in the last 50 years is like,
A
so say that's
fraction of
this
what's gonna
trajectory.
happen,
That same amount of advancement could happen in the next 5 years, and like it's just gonna keep
We already
going
have
up and up and
CRISPR.
up and up and up. Like CRISPR is bananas.
Yeah.
Like
We basically have gene editing technology at our fingertips right,
Right now.
There's a company that's
And it's
making it
cheap.
for home delivery.
it's
Oh,
cheap.
really?
Yes, they're
Yeah,
like
it's
chemistry
like
sets
$100.
for CRISPR.
It's
Really?
crazy.
Wow.
Yes.
Yeah.
So,
yeah.
I mean, this is absolutely bananas. So the idea of thinking into the future 50 years right now, in terms of quantum computing, is like all I can do is just.
All I got is graphics cards. That's
I mean-
all I got.
I mean,
But the thing is, like, quantum computing and graphics cards could be here in 5 years, 10 years. Like,
They-
it's not.
it's one of those things.
It's
It's,
not
like with computers, you have to get over a
reasonable.
certain
I don't
hurdle.
know.
5 years
You have to
is
get
too
over.
soon.
Yeah,
But the
you have to
thing
get
is,
over a
like-
certain hurdle, and
Yes,
once it's good enough,
Of course,
then, yeah.
but like we honestly
not popular
do not
yet.
have any real comprehension of how fast this shit is gonna happen.
Sure.
So it's like, even if right now we're like 5 years, 10 years, like in my mind, I generally err on the side of conservative for a lot of
Yeah.
these things usually, but like because this curve is happening, like we don't know really where we are on it,
Sure.
and we don't know how fast it's actually going to happen. So it's like, who knows what the fuck's going to happen? But like the real reality here is that like we could have a quantum computer that could perform crazy operations within, I don't know, what would
I
you
mean,
say
so
your
they-
conservative estimate
Well,
is?
so I
for
mean, the
this?
immediate applications for quantum computers are like we talked about cryptography and like information
Right.
security.
numerical computing, like
Yes.
like simulating the birth of the universe or something like that.
Yeah, sure. Well, yeah, so cryptography and then anything where you're simulating atoms or molecules even, right?
Yeah.
And so that's a lot of chemistry that we do, especially
Yeah.
biological chemistry, and we're trying to figure out
Anything
like
where you have to search
how
a
the
lot of things
molecules
or a lot of things
interact
happen
and
at
stuff
the same time.
is super complicated, and our computers do it, but it takes them a long time to show the interaction between like molecules in our body and stuff.
Right, totally.
And since those molecules are quantum objects, we can pretty simply use a quantum computer to simulate them.
Yeah.
And then boom. So that could open up huge gateways into the biological sciences and gene sciences and things like that, genetics.
Totally.
So those are the immediate ones. that
Yeah,
I
for
see.
sure. Yeah. All right, let's bring it back to chat because we've got some really amazing stuff going on in here. Okay, so for a little while back, we have Lady Luthien who said, 20 years ago, I bet people never imagined VR would be commonplace, but now we're using it with our phones, or at least augmented reality.
Because once you make that one initial leap,
that
it can become common, then it changes everything.
It's like
which is cell phones, really.
It's very.
For us, it was
it's
cell phones.
similar to genetics. It's like a genetic sweep. Like once you have some mutation that is so unbelievably important in terms of a fitness advantage, you will have a relatively rapid sweep among the population where it just
their kids fuck everyone.
Well, not only that, their kids fuck everyone and have tons of fucking babies. It's about having babies that are viable, not about fucking.
Who also fuck everyone.
Yeah. So but no, it's not about fucking everyone.
Wrong.
Stop being so sexual, Eric. No.
It's reproduction. Come on.
Yeah, but but it's not about fucking everyone. It's about fucking everyone and actually having viable offspring as the result.
Of course.
Right, but fucking break it down, yo. Come on. Anyway, that was just
No, I'm not complicated enough.
I'm not getting enough.
No.
These are the biological
want it to
people.
be
These are the
complicated.
anthropologists here.
Anyway, that's just an example. You have one thing that comes out that uses augmented reality, like Pokemon Go, and it's so
Quantum
new and
Pokemon
so great.
Go.
Oh my god!
I have
Pokemon.
I have every Pokemon and none of them at the same time.
A wild pale ale has
appeared.
A wild weird concoction has appeared at the same time.
Oh my god.
What do you do?
And then they have sex and they have a baby Pokemon.
This is madness. This is science.
Which, by the way, is totally a thing that happens in Pokemon, so you can't.
Well, they don't reproduce; they evolve with the stone.
No,
we
or
can
something.
breed them.
We need to have a
You can breed them.
Pokemon episode, apparently.
You've been out of it for a
that
while.
There is
thing?
a lot of
It's
latent...
been for there for years.
The silver and gold.
There's
like
a lot
a
of
decade
latent
ago.
Pokemon
I go back to
angst
red and blue
or something.
Yeah.
I
I miss
don't
the
know if I get
glitches.
But what the fuck? Because we should
Guys,
have
we can
whole-
have a Pokemon episode, okay? We can have a Pokemon episode.
The science
And
of
this is not the Pokemon
We
episode.
actually should have this. Because, honestly, it's an evolution episode a little bit.
But the thing is, isn't that basically the science of animal fights,
Well,
which
no,
is sort of
so-
really ethically
Okay,
questionable?
hang on. Let me just have a little aside here,
Is
okay?
Bulbasaur
The
or
reason-
Charizard the
wait,
better
wait.
starting
No,
Pokemon?
no.
Discuss.
That's. I feel like that's a little racist or Pokemonist or something. I don't know, but the reason why I chose Team Mystic, is because it exists to study the evolution of Pokemon, because that's what I do normally. But the whole you could talk about I study evolution in general.
Right.
Human, I choose you.
But the evolution Pokemon is so weird and not actually real evolution. So we could actually just talk about evolution in a Pokemon
It's practically
sense.
fucking Lamarckian.
It is.
Yeah.
Well, I mean, it's different. It's almost. It's more environmental in some way because
Have you ever seen
in a lot of
Dragon Ball
them you have to.
Basically, it's the idea that
with
if you got
Eevee,
strong,
you
your
have
kid
to
would be
apply
strong.
a stone
worked out.
to get a Flareon
Because
or
you're
whatever.
over 9,000.
So
Yes, exactly.
that's an environment thing that's very different. It's almost an epigenetic sort of. It's kind of.
Epigenetics is the biology equivalent of quantum physics.
Okay,
let's
where everybody's
let's
just
bring it back.
epigenetics.
We're
Go.
getting
You guys.
We're getting a little crazy here. Okay. Anyway, let's
That's how you
bring
know
it
it's
back.
kicking in. The alcohol's
I'm just
kicking
gonna
in.
run through some of these
Okay.
amazing comments in here. Singularity-gasm. I'm not even a science guy, but this chat is pretty entertaining.
Boom.
Also,
I'm
OMG,
entertained.
can we please talk about the observable Eunice?
Eunice.
I am not a
Singularities.
observed the
Key lime
universe.
pay.
And new
We need some
discoveries
key
in
lime
space
pay.
and time. Yes, we will totally talk
Yeah,
about this.
that'll be a separate
we have
episode,
had
yeah.
one space episode so far, but there's an infinite number of space topics we can talk about.
So many.
So, but yeah, Space Nerds is fucking right. This is how the AI take over. Totally true. I mean,
Via our show.
we'll get there.
Yeah,
I
right.
know. Maybe we'll have AI take over while on air.
Yeah.
Exclusive. Okay. We'll be playing Pokemon in our dreams with a quantum thing attached to our heads from Classy Bathrobe. Maybe. I don't know. Maybe we can...
I hope so.
Maybe we'll someday have an implant where we can actually physically see Pokemon in real life.
Ooh.
When the Pokeball is shaking, it's in a quantum superposition of caught and not caught until
What?
it gets resolved, and then you know whether it's caught.
God!
I don't
Yes!
like it. I don't like it.
You're
I
totally
don't want
right.
That. No.
Sometimes
No.
it pops out.
Yeah.
And then sometimes even if it pops out, you don't know if it's going to stick around for another roll or if it's going to go away.
Shut
And where does the
up.
Pokemon go? Is it encoded in like
It runs
quantum
away.
information?
And it's got a bunch of dirt.
I don't
Like-
understand Pokemon
Professor Oaks.
or quantum stuff.
Okay, this is getting a little crazy. But
You shouldn't have started reading the comments. You this would
I know.
happen.
this is,
The
yeah.
comments are a dark, dark place.
This is getting a little bananas, but yeah. Okay. Oh, hey, Wicked Kender, welcome back. Lawnmower Man taught me all I need to know about VR. You should tell us. Teach us about what do you? Yeah, I want to learn all these things. Also, I vote that Scott be here for the Pokemon stream.
I will soldier through it.
Wait, is
Are you
he
not a
supposed to
Pokemon
represent the
fan?
normie? What?
I mean, I played Pokemon. Who didn't play Pokemon?
Yeah.
But I don't know if I could talk about it for 2 hours.
I could probably talk about. Well, I don't know.
Yeah, I
so,
really know the original 150. I played Silver also, but that was it.
So
Well, okay.
hang on. I'm gonna do a thing because I'm a little drunk. And I'm
Oh, so are we
sure
gonna get to the
guys-
game?
Hang on, we're gonna play games
Oh, yeah.
in a second, but
Can I go to
just
the bathroom?
wait. Yeah, here we're gonna.
What?
Woo!
No, I'll
We're
just be
gonna
right
take
back.
a
I'll be
potty
right
break.
back. I'll be right
But
back.
Again?
also, I'm gonna come back with a special guest.
You should have gone when we had
Hang
the
on.
last one.
Quick potty.
again, I think.
No, no more bathroom breaks.
Again,
No more.
back. Okay. So I can't guarantee what these are going to look like on the green screen. But the reason why I had a break is because I wanted to bring out my Pokemon card collection. And I have, Eric was talking about the original 150 or whatever. And I actually have all of the original
151.
151, yeah.
Yeah.
So I have the whole original collection. I have like
Shinies.
70% of the jungle and then like 60% of the fossil. So yeah, like it's legit.
Pretty neat.
They're in
Okay.
sleeves.
You're just like, what the fuck does that even mean?
Okay, I have a bunch of magic cards, so I probably can't judge.
I've got, these are all the shinies. I've got Mewtwo
Oh, wow.
over here.
Look at that.
And several
Wow.
of these are actually first editions.
What?
So that means that they are potentially worth some money.
First editions?
I shouldn't have given mine away. I knew it at the time when I was
know.
like 15.
Well, so they like actually boost. The reason why I like went through and cataloged all of them and like took care of them and stuff is because they were kind of like bumped up in value recently when Pokemon Go came out.
Wow.
Sell them while it's still popular.
Oh no Screen Pros. Oh my god. But anyway, so I have a lot. And I have multiples of some of these. Not any of the like big ones, but
It's actually not a bad card game.
it's fun. I had a great time.
There actually is a lot of strategy.
I honestly didn't play them that much. I probably played like 2 or 3 times, but like
Yeah,
I was
same.
just super into collecting.
Yeah.
And so like, I've got
Do you have
Tons.
Blue
Was
Eyes
the actual-
White Dragon? Blue Eyes White Dragon?
I don't know what that means.
It's from Yu-Gi-Oh!
I don't know what that means.
Don't worry, it's not worth
then,
knowing.
Then we can move on to the...
I used to play it.
I just wanted to ask. I didn't know.
I've got a sparkly fucking Snorlax, so,
I'm learning a lot lot about you on this episode.
Dude, this is...
Apparently my
like,
sarcasm
so
is
I've
too
got-
harsh for New Mexico.
I have a first edition Shadowless Butterfree.
Shadowless
so,
Shadowless
I
Butterfree?
went
What does it
through
even
a
mean?
Bananas,
There's no shadow in the
thing.
background.
There's no shadow in the background. And it's
There are
a
two
first
different
edition, and it's like so.
I mean, I
the way
understand.
they're- Yeah.
I don't like it.
The way they're valued is like if it's first edition or
Yeah,
if it's shadowless or whatever.
I have
And, like,
magic
I went
cards, too,
I went
yeah.
through the fucking rabbit hole when I first
Wow.
did this. This
And by
is
when
my
you first
prize
did this,
card.
you mean like 3 weeks ago,
No,
right?
this was-
is when you started.
This was
down
like
that.
January.
Okay,
so
yeah.
close.
Closer.
I collected these. I mean, these are all.
We're
like,
totally off topic, by the way.
original.
Yeah, really. We're
Like when I was like
extremely
13, kind of thing. But like this is my favorite, so I fucking love Dragonite. I don't know why.
Dragonite, wow.
I didn't even realize as a kid like how potentially powerful it would be in Pokemon Go. But like my favorite, and I have the sparkly one, so
Wow.
Anyway, let's move on.
I'm just gonna put these.
That
in
was like
my
a good,
backpack.
what, 5-10
I'm
minutes
just gonna
there?
take.
So I actually made up a spreadsheet of these, and I think like conservative value is.
We're
probably,
really
like,
going down the
200.
rabbit hole here, aren't we?
Yeah.
This is.
We're in the multiverse where
She
Pokemon
wants
Go
you all
is
to be
taking over.
jealous.
Quantum Pokemon Go. That's right.
Ah, yeah.
Are we gonna play
Alright,
some
let's play some
freaking
fucking
games?
games.
Play some
All
games,
right.
because that's what Twitch is here for.
All right,
Pokemon
let's
and
do
video
this.
games.
Okay.
That's actually not
So
inaccurate.
I hope you guys enjoyed the rundown memory lane or new memory lane. I don't know. With
Spreadsheet
Pokemon
lane.
cards, spreadsheet lane, totally. All right, but we are going to switch over and play some games with some fucked up physics. Well, actually, one game with fucked up physics that's super fun.
I like games.
We're okay. So hang on, wait.
What?
Thank you
What do we
guys for
got?
such an awesome show. My tyrannical right brain leaves my left brain craving this type of nerdgasmic discussion. This was fantastic. Yay!
Glad you liked it.
Awesome. Thank you so much. I'm so glad you tuned in. But we're gonna start. We need controllers.
Oh no.
Yay! All right. So
You have one, right?
yeah.
This
So
is
what
gonna
we're
be
gonna
utter
do
madness.
now?
This cord's really short. It will.
What are we
There should
playing?
be a
What do we
bit,
do?
right?
Whoa,
Use
shit.
them.
That really?
That's Lily.
Hi, Lily.
That's Lily, and then Toby's the other one.
We're gonna start
Where's the
playing some
dogs?
games.
Big
We also have a dog invasion happening at the same
Jesus.
time. Oh my god! Oh, I didn't have my mic on that whole time.
Popcorn.
Take the gypsy bug.
Yeah, well,
You didn't have your mic on?
No! I hope they can hear me.
Dog.
Oh, nice.
What did you give
It
this
did,
look like?
it did
What are you doing?
register at me for a second. that you had done.
All right. Okay. So that sort of concludes our general discussion of quantum physics. But now we're going to play some games that have some really crazy physics to them. And the one that I picked for this
What is
is Gang Beasts.
Gang Beast.
Yeah.
It's the whole gang of them, not just one.
It is a gang.
This sounds
Not
wrong
just one game.
somehow.
Yeah, I
That
know,
title
it's a
sounds
little
wrong.
strange, yeah. But we're going to play some Gang Beasts. It has crazy physics in it, because like
Okay.
one of the sort of parallels to gaming when we're talking about physics is that when
Not
you
quantum,
create,
though.
Not quantum. It's
Newtonian.
classical Newtonian physics. But like every time you create a video game, you create your own physics.
You have to create a
Sure.
universe, basically.
Yeah, you
Yeah.
create a universe. And so like every game that you build has to have its own physical properties.
Right.
And so we thought it would be fun to kind of tack on to the end of this episode to just play this game because it has such weird physics to it.
Yeah, nice.
And so like basically
They're actually more normal than other, like, it's just the,
it's just
It
in
applies to more of your
movements.
body.
It's
Yeah.
movement. So it's like almost like a
shit.
biophysics
Oh no.
weird thing.
It's biodigital
So,
jazz, man.
Yeah, that's exactly what it is.
Like, this is
That's
what
it.
happens
We're
when you
gonna
apply
go
physics to
Tron
the whole
Legacy.
character.
Totally.
Yeah.
It's crazy
All right,
though.
let's do it. Let's do it.
If I
I'm
had
ready.
to explain what Gang Beasts is like, it's this. It's basically those fucking blow up things you see at car dealerships,
But they're fighting.
but they're fighting.
I
It's
used
great.
to be a gang beast
Oh shit.
in my younger days.
Oh shit.
I was a gang beast.
Okay. All right. We're gonna make this happen.
There's nothing more to say about that.
I was literally.
Do you have a
speechless.
tattoo from your gang beast days?
A what?
A tattoo from your gang beast
I
days?
do, but I won't show you it. No,
I
won't
don't
show you it. Those were
Okay.
dark times for me.
All right.
Very
Of
dark
both
times.
beasting and
What are we
gang.
doing?
We're gonna move over to our gaming stream. So wait for it.
Whoa!
Oh
Whoa.
snap! Oh
Whoa!
snap!
Oh, this is cool.
Yeah. So we're small now. Yeah. Okay. All right. So now we're gonna.
Does your dog
we gotta
ever
get the-
calm down?
No, never. So we're gonna actually play on
Wait.
this computer.
Okay.
So we're
Can
gonna
you
have
like
to, we're
move
gonna
the
move it
computer
over.
up? So yeah.
We should actually. Could the studio audience move the Pokemon cards away so that it's not in danger? Okay.
You just put them in your room.
You could just put them on the table in there. That's fine.
Who you got?
Okay.
FTL? I've not played it, but I've heard
We
good
have
things.
That feels
lots.
really good.
We have lots of.
It's
things.
like a
too.
space roguelite.
Okay.
Fears.
We are gonna start playing.
What else you got?
You're just gonna review
Yeah, I
a game
know.
Yeah,
library?
Oh, shit, yeah.
I've got my own, so I wanted to see what they got. What is this?
Okay, so you guys are probably gonna have to control this now. So you're gonna want to do local.
Oh, okay, you.
Oh, I didn't press
What
anything.
happened?
I didn't press
Okay,
anything at that
let's
point.
try
Yeah,
again.
you did.
No, I didn't
Try
press a
again.
button. You quit. You're the one who quit.
You pressed a stick then.
Yeah,
Oh, yeah. All right.
because I thought I had control.
Okay, then you do it. You do this.
Okay.
Okay.
You have to join.
All right.
How do I
So
join?
you've
Press
got
a
to
button.
press a button.
Okay, all
There
right.
you
I'm
go.
Flurb 1.
Okay.
Oh, here we go.
My dog is stepping on my
I'm
mic
gonna
cord.
be the.
There we
Oh, I'll
go.
be the shark. Yeah, I'll be the shark
Yeah,
guy.
you guys can choose whatever you want. So you're these little guys, and you can change the hoodie. You can be a little chicken. You can be a corporate
I'll
man.
be a dad.
Be a dad. A dad beast.
Shark
Dad
versus
beast.
dad.
Dad beast, shark versus dad. Who will win?
Hi, little girl.
Okay.
What do we find game? What do we? I
Let's
just
try
want the
find
two of
game.
us, right?
Try
So-
find game.
Yeah, so find.
we can find game.
No, you guys are in multiplayer. You gotta go back. You gotta do local. Yeah. Go
Oh,
up to local.
you didn't
There
do
you go.
locally.
I didn't do
There you go.
anything.
Yeah, okay.
I've not touched this.
All right. So
Melee.
game mode is melee.
Yep.
You're just gonna beat each
Go
other
but
up.
good. Yep.
So wait,
Right,
stage.
Yep. Yep.
Stage. Let's find. We're gonna. I think there is a random one. Let's do random.
Grind. Incinerator. Wheel.
No.
Limp.
Okay.
Limp.
Oh,
Limp.
random on.
Limp.
Yeah. Start
Limp.
wherever and then do random on. transport that one. Okay, cool.
That's
All right,
three
so
lives.
then you want to do 3
Endless
lives? Endless is like you just keep fucking going or whatever. Just turn
Okay.
you leave that. All right, I think we're good.
That's good. You start at the top.
Yeah.
So what are the controls?
So,
Shark. I got
yeah,
my shark guy.
choose your thing. You're gonna just
I don't
figure
know
it
what
out,
the
yo.
controls are either.
Whoever loses has to drink. Totally legit. Yes. It's tournament style, so you've got 3
You
lives.
need a, I have a
So
shark.
like,
I have a shark beast.
do it.
And
Yeah.
you need a dad beast.
Yep, I am.
And you're like,
That's A.
Beast
you have a
dad.
shark beast that's like
That's A.
super
Oh,
pumped.
There we go. Oh yeah.
Oh yeah, super
Shark
pumped.
V man.
All right, I think
Beast
you guys are
dad. Neither beast nor dad.
I don't know if you knew this, but the shark is the most powerful character in this game.
ready. Yeah.
In fact, in real life too.
Yeah, if
All
you wear a
right,
shark hoodie,
you guys
you're
are on a
badass.
blimp, and the object
Oh.
is to throw
Oh
each
my
other
God.
off of it.
Come at me. Come at me. Come at me, Dad. Oh no. Oh God. Okay, wait. I don't. No. Stay
Okay.
away. Stay
Okay.
away from me. Stay away.
What do
I want to figure out what I'm doing.
How do I grab him?
You gotta figure that shit out, yo.
No, no, hey.
Oh no! They both fall down.
You did this, Eric. You did this. I was perfectly
Well, I thought
content.
if I was gonna lose, you were gonna lose.
I was just hanging out on a blimp, and
I can't figure
Okay.
out how to beat the shit out of you if I don't have access to you.
So I think one of the controls is kicking, one of the controls is
Oh.
punching.
Oh.
Fuck you!
That was you this time.
That was you this time.
And
I
one
think I
of
found
the
out how to
controls.
punch.
So I think one of the
down.
triggers
Yeah.
or
Oh,
the
yeah,
bumper
yeah. Okay, yeah.
will allow you to
Dog
hold
is going
on.
crazy.
So if you punch somebody and then you hold on,
Yeah,
you can
okay.
actually hold on to them and you can throw them that way.
Oh.
You can also lay down.
Punch you.
That's
I'm
another
a
fun
punch
way.
you. Oh, there we go. I found out how to punch. Die. Get. All right.
Don't fall off! Don't fall off!
Oh, no
Oh,
punches
no!
with that one.
Wait,
Punch.
which one's punch?
Oh, come at me. What? I'm
So,
in.
yeah, you.
I'll get
you
up
gotta-
the blimp.
there
Get
you
up the
go.
blimp. I feel like I should be like rapping right now.
No!
No! I was innocently.
I don't know how to punch, but I can headbutt.
I was innocently trying to sing a
my
song,
God.
Eric, and you punched me
No, I headbutted you.
or headbutted me.
Oh
What-
god. So while you guys are figuring out these controls, how does this physical world differ from our own?
Really?
Yes! Really! Go there!
Not that much. I like to hang out on tops of blimps. Dude, I'm grabbing you and I'm punching you. This is brutal. Look at that. Look at
How do
that.
I do any of this?
Say uncle. Say uncle. Say uncle.
How do I do what?
Eric, name 10 cereals or I won't let you go. Go. Eric.
Fuck it, I don't eat enough cereal.
Eric, say
Okay, I'll name cereals for you. Fruit
Say-
Loops,
there-
Honey Bunches of Oats.
Captain Crunch.
Yeah, Tricks.
Oh no.
How do I punch? What the fuck? I can't do anything. Okay, I see.
No. Hey, get off of me. Get off of me.
Oh shit!
Oh, come on.
shit! Dang. Eric wins that one.
Booyah.
All right, I'll get in.
Okay.
Get Kate in on
Let's do
this
it.
because Eric beat me because
we're
I
doing
was
that?
trying
Okay.
to, come
I'm
to some.
red, right? Yeah.
I was trying to just have a conversation with the other guys on the blimp.
I don't even remember the controls on here.
Oh, ouch. Oh my god. Oh. Yeah, yeah. Oh no.
Oh no!
no.
No!
What's going on? Just grab him. Punch him in the butt. Punch him in the butt. Punch. Oh no! Oh no!
Threw myself
Oh!
Oh my goodness!
No!
Dad Beast with the win. Dad Beast is.
No one can beat a dad.
Dad Beast descendant. Yeah, right.
I don't care if
All
you're
right,
a
get
shark
back in
or a
that bag.
dinosaur.
All right. All right.
No
Come
one
here.
beats a
Come
dad.
here, you punk. Come here. I was raised on the streets of the blimp. Yeah. Get what? No. I couldn't move.
Clearly, I'm the superior physicist.
I could not. I think you've got a dad gut, and so you've got way more mass
More
weighing you
mass,
down.
yeah.
Way more
Oh my
mass.
God.
But you have
Alright,
clothing
So we need
that
to
weighs
do,
you down.
turn on endless, and it'll keep
Yeah,
going
okay.
to different things.
No,
And you should
I'm
pick different
I'm
ones.
doing now. Stop.
That was my job.
Try
Just give
let's
me a
do-
job
Let's
and
do
then
elevators.
Yeah, elevators first. And then
endless.
turn that on, yeah.
Shark's not doing it for me.
You want to do Nacho Libre style, or
Is that a construction worker?
maybe?
Or a professor? Office worker. Yeah, I think I want to do.
Yeah.
Nacho Libre going on here.
Luchador. There's actually like 3 different luchadors.
Yeah, right.
Okay, there we go.
You're gonna. Right.
Dad beats everything.
Testing a hypothesis.
Dad's
Yeah.
gonna die.
Dad humor.
Oh, this is
The best humor.
Yeah,
Oh, we're in
maybe,
elevators now.
maybe.
Come here. Come here. Come on, get here.
Why can't I
I'm
break
breaking windows because. Get in there. Come at me. How do I throw you? I just want to throw you. Oh, no, what are you? I'm so weak. Don't kill me, I'm so weak.
No, you broke the elevator glass. Oh shit.
Stop it. How did, there's gotta be some way to like, throw you off this.
I did that to myself.
Yes!
That'll work.
Fine.
Alright.
Alright.
I regret my choices.
Hey, we're just hanging out in an elevator. What's
We're
up?
just
What's
hanging
up?
out. What's up?
Okay. So, did you see that new Star Wars?
I did not.
You didn't?
No, I
Just
didn't.
one Star War, not
One
many
Star
wars.
War, yeah.
There's only one war.
Well, who
I'm
is your
just gonna lay
favorite
down.
character?
In the new one? Like the prequel one?
Yeah.
I honestly didn't like it.
Yes.
Okay.
Star Wars.
Okay.
I'm just gonna lay
That's
down
it.
and
That's
that's
it.
gonna be my strategy.
Say.
And this might be an unpopular
Say.
opinion. I don't know, but
Ah.
I did not really like Rogue One very much.
Oh, in that one, yeah.
Oh,
really.
shots fired.
I
Oh,
liked
no.
Force Awakens.
Oh, no.
I loved
Get
Force
out.
Awakens.
Really?
Get
That
out.
was basically the original Star Wars.
No, Rogue One was the original Star Wars.
So was The Force Awakens.
Yo, but like you knew.
Oh, geez.
Oh shit.
Oh, my
No.
God.
I knew the whole plot.
We died.
I
Totally
knew.
just died.
I knew like the whole plot going
Somebody
in.
said,
Well,
Like-
that's how I felt about Rogue
somebody
One.
said, what did I come back to? Drunk
That, like,
elevator fights?
You know exactly what happens
Yeah.
at the end, so like, what's the point? I don't know. It was just super cliche.
Well,
I guess you're their audience.
Yeah.
Because you hate Star Wars.
I think
Who died?
I think the graphics are having an issue.
Or wait.
Well, we both died.
It's going
We
kind of
both
slow.
died, but you can.
Here, you can go
No,
for
no,
it.
no,
yeah.
no, you
no,
go.
No,
okay.
you died. So
I'm on
No,
top.
Star went against
What?
you.
Okay. I'm gonna figure out what my controls are here.
Yeah, I agree. This is how a lot of my fights in elevators go. You know, I'm usually in one
Open the
elevator.
elevator?
Oh,
Oh fuck!
Wow.
Oh, why can't I go through?
I see a
broken.
dad in the other elevator, and I just get angry, and so I
I'm
want to go.
trying
I
to
want to jump
jump.
over there. Oh no! Oh no! Oh! Oh, he's throwing him around. Yeah, show that, Dad. Drag him out. Drag him out. Oh no!
Oops.
That backfired. I think that backfired a little
I
bit.
know.
No, you'd straw.
No, it's alright. Keep going.
Okay.
It's okay.
Okay. All right. Here we go. I'm on top of the elevator now.
No, you're not.
Oh no! Okay.
You did totally
that was
come back
me.
to drunk elevator fights. That's
That was
exactly
me.
what's going on.
I tried jumping. I swear I tried jumping.
Wait, who am I playing as right now?
Your dad. Your
Dad. Okay.
Your
Dad
dad.
piece. Oh, I'm like, I'm trying to jump, and it fell off.
So I can actually talk sciencey about this.
Yeah, do it. Yeah.
Okay. So
That's the idea.
Oh.
So basically what they're... Oh wait, what the... That was you.
That was me?
Your dad.
Am I
What
dead
just
now?
happened?
I think we're very confused. I think we're extremely confused as to what's happening right now.
You know what's not confused?
Okay, so I'm
Science.
Dad. I'm Dad.
True. Okay.
Okay,
Let's
all
do
right.
this. All right. Play some games
Dad
and talk
is-
some science.
Wait,
Dad is
which
a
am
little
I?
Oh!
Which one am I now?
I just said I'm Dad. I just
Yeah, but
said
it
I'm Dad.
didn't feel like I was Luchador.
Tell me how you felt
What is
about
happening?
jumping off that elevator.
Oh my god.
So,
Okay, let's actually
this is
talk
basically-
about.
so this game
Falling off the elevator.
is based on ragdoll physics.
Yeah.
So this
feel
is
bad.
an active ragdoll, which
Yes,
means that
new
they're
stage.
mixing. That was you. That was all you.
What happened?
Which means they're mixing.
I feel like my controls keep. Wait, is that what random means? Does random mean your controls keep switching?
I think it's just the stage.
Okay.
But I don't know. I think it's just the stage.
Oh no, cause now no, something's weird. Something's weird.
Well, his
and I gotta get
because
this
you have his
nacho.
controller now, so it might have been different.
Ah!
Oh! Yeah.
So
What is ragdoll physics? Let's talk
So-
about this.
the characters have skeletons inside them, which are like simple skeletons, not as many bones as we have. But they're
Stay away from me.
used
Stay away
to
from me.
map
Stay away
the
from me.
movement of the limbs and to constrain them so you can't, for example, have your hand fly away.
Come here.
It has to stay attached.
Come here.
It's really difficult to have a
shit.
serious explanation
shit.
during this.
Get in here. Just no. I don't want to go. 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 I don't want to go.
What is happening?
And so
You made me. You made me. You made me.
during normal animations,
That was like a mass suicide.
you map out the location of all the limbs beforehand by the animator, and then those positions are recreated in the game for like a running animation.
Yeah.
And so, or you can ragdoll, which
Ah, no!
you keep the skeleton, but you apply physics to the skeleton.
But not the everything else.
Yeah, and so what you do during active ragdoll is you mix between scripted animation or controlled animation and
Right.
the ragdoll. So you're
Okay.
basically saying, do what I'm telling you to do, except fudge it a bit based on the physics.
Yeah.
And so in this case, what they're probably doing is they're applying physics only to the hands. I mean, they're applying like animation only to the hands. So they're based on what we're putting in.
Sure.
It's adding force to the fists,
Right.
and then but the rest is just physics. And so, for example, it looks like we're walking, but from when I looked up, there's actually like an invisible ball. So they're like walking on invisible balls that keep them from falling
my
over.
God.
And so it's basically 100% physics. Like
That's
even,
incredible.
even our punches, they're basically just adding force vectors.
Yeah.
To the
Yeah.
fists.
You've got what did you do to your arm? Is this some like drunken sensei style? Take out the trash. Take out the trash. Who's taking out the trash?
Shit.
Brutal!
Oh my God,
Brutality!
that was totally brutal.
Dad is master of physics and master of drunken fighting,
All right, get
as
it
you can
right.
tell from his beer gut.
Alright. I'm not Joe.
Right now.
Okay. Hey, Dad, stop it, Dad, I just had a couple beers with the guys. I had a couple bevies at the pub. And I don't want to go home. Stop it. You're making me angry now. Dad, I know when you're drunk you get like this. Oh,
That got
Dad,
really dark.
Dad, okay, this is,
Master of drunken boxing.
this is not good, Dad.
Oh gosh.
He's an abusive father.
Dad, you should not be proud.
Also, why? Maybe he's just angry because his son became a fucking luchador instead
Dad,
of a lawyer.
okay,
Maybe,
Dad,
Although,
Dad.
don't knock the luchador. Come on.
Well, okay, as long as he has, a stable retirement account.
Right.
Sure. Maybe you become a really famous luchador.
I feel like,
And you can make a lot of money.
okay, now I can
You
jump.
enjoy it.
See,
No, that was me.
Oh, you
And
can't.
you both fell
You
off.
can't. Man, something's
Dang,
weird about
that's
these controls.
Yeah, it was hard
That's
to
kind of
jump.
the idea.
Yeah, it's hard to jump.
Yeah.
It's
Tell us more. Oh, come on!
God damn it! Everything's delayed because the ice, I think. is
Yeah, I
delaying
think so.
all
All right.
the action.
Well,
Oh god. I've
Hey.
never played this level actually.
hey, Dad, I just want to talk to you. Things have been.
Are you
rough.
gonna go back to law school?
No,
Is that what
I
you're
hate law school, Dad. I want to be a circus performer. Can't you tell by the costume? Dad, you're being mean again, Dad. Stop it. Dad, stop it.
Really dark.
Dad, stop it. Stop it, Dad.
You're going for a swim, son.
Dad, okay, let's
This
calm
is
down
really
and talk
dark.
about this.
Oh,
Dad. Okay.
Yo, you're
I
going
know
for
we
a
like
swim,
I know we
son.
like
Hold
wrestling.
hands.
I know we like
Holding
wrestling a lot.
hands,
Let's just go watch a movie together.
Let's hug and be friends.
Let's go to McDonald's, Mickey D's. Dad, don't make me angry, Dad. Dad, ow!
Oh!
Look what you did to your father.
Oh, Dad.
Okay, your turn.
All right, let's do this.
Oh, hey, Pooch. Oh, God. Okay.
Oh no! What the fuck?
You broke the ice?
Yeah.
I missed it.
I was like holding onto the ice and then it just like snapped.
Oh,
Yeah.
wow.
Oh my gosh. Okay.
Nice jump.
No!
Oh,
Yeah!
Victor, do a victory dance. Victory dance.
Oh yeah.
Yeah, nice. You lost.
Dad will rise again.
Oh god. Okay.
Let the dad beast out. Eric.
Oh no! What the fuck?
Shit.
That doesn't count.
Works for me.
That counts. You died. Dad is not faring well.
I won that one. Yeah.
All right,
we-
Kate.
yeah.
All right, here
let's
we
do
go.
This.
Let's see if you can dad better than me.
We're on top of a nuclear reactor.
We are.
Case in point, radioactive decay is a
I'm gonna
quantum
work on my-
process.
Yes.
It's a probabilistic
Hence
process.
Schrodinger's cat.
Okay.
Radioactive
okay.
decay is behind that.
Hey, just calm down. No. Just here. Come over here. Come on. Just calm down.
How do you throw people? It's so.
Okay, come down here. Come down here. Come down.
No!
Please. I want to show you something down here.
No!
I want to show you something down here.
No!
Oh, God.
Let go.
Oh, no, I want to. I'm doing ballet on the.
What is happening to the table?
I'm doing ballet on
Your dog.
the rail. Hey, I want to be an actor.
Let go!
Ow! I can't. Just. Oh, we're still
Oh my
alive.
God.
We're still alive.
Okay.
Hey, come here, Nacho. Come here, Nacho. Mama, Hey, ow. Just, no, stop it.
Every time I try to pick her up, she jumps back. Ninja.
Not like this. Not like this.
No!
Not like this.
No!
You have to let go. It's the only way.
I'm going
Oh.
here. What?
Oh.
I died!
See,
My
Dad
phone
is
down
the best character.
Alright,
He
get in
kicks
there.
ass.
Oh, Lily. Oh, goodness. Are you going now? Okay.
Now I'm the luchador. Fuck you, Dad!
Oh,
You're going over!
I just wanna headbang. No. Hey, look at that! I got back up. I want a pummel horse on this railing. Stop it! I want a pummel horse on the railing. Just Eric.
You guys look like you're about to kiss.
Looks like we're tangling.
Yeah.
Eric. Just Eric.
Oh, that was a nice headbutt.
Brutal.
Oh!
No.
Oh, shit.
I'm okay. I'm okay.
Oh!
I'm
No!
okay.
No!
I just want to live.
Oh my gosh.
No. Just get no. Okay. You know what?
For years you've talked out of me, Dad. You've disrespected my dreams. And so now
You're coming with me. Come with me into the abyss.
Oh, shit.
that's what you get for the divorce.
For the
Too many
This is getting terrible. This is getting
Why
terrible.
is this so dark?
Do you have an episode on daddy issues?
I know. What
I think we should.
If we do, we need to play this game apparently.
No. No.
Dad, I know
What is happening?
I know your job at the nuclear reactor isn't going so well, but you don't have to take it out on me. Eric is brutal. Eric is just brutal.
Damn.
I keep it on the
Damn.
inside.
We are indeed working through some things here.
All right.
What the fuck?
Drunken dad style.
Guess I should change this to
You're going nuclear, Dad.
English.
Oh! Whoa! Get. Nope, I'm going down here. I don't want to hang on anymore. No, I do want to hang on.
Oh, bruh.
Come down here. Get down here, Eric. Get down here.
I can't, because I can't see what the hell I'm...
Well, how the tables have turned!
Oh shit!
Nope! Fuck!
Oh,
Yeah.
the
This is what I get for listening to you, Dad.
I just want a bachelor's of art degree, Dad. That's what Kangaroo Beat said. Don't tell me what to do. Don't tell me what to do. Dad ascendant. Oh, look at that pose. Yeah.
I'm gonna prove to you that I can make it with a liberal arts degree by destroying you.
That's not how that works. Hey, okay. Just no. Okay, you know what?
Oh my God.
Dad is just. Ah. No, stop it. I keep hanging on to railings for no reason. I don't want to hang on to the railing anymore.
Don't let go.
I can't. I'm not. I'm king of the world. I'm Some dad came into the world.
That's right. Dude,
Oh.
you're blowing up on Twitter, yo.
Oh! Are we?
The live tweeting.
See, look
Love
at
it.
I keep hanging on the railings for no reason.
Yeah.
I don't want to hang on the railings. I want to hang on to my son because I love him so much.
Let's hang on to the reactor itself. What
I'm
is
climbing
going
up. I'm
on?
climbing up this wall.
What
If it's the
fuck?
last thing I do.
Ah,
Come
what?
on.
You're
Come
like
on.
Spider-Man.
Come on. I'm like
Get
Spider.
it, get it, get it, get
Oh,
it. Oh,
okay.
no,
No, you
don't
don't.
fall off.
No.
Don't fall off.
I just
What
never let
happened?
go, Jack. Never let go. Oh.
I'm crying like all the 13-year-old girls during Titanic.
I wanted to hang on. I wanted to hang on.
I was one of those 13-year-old girls when Titanic came out.
Were you really? You were thinking of girl at one point?
Yeah, I was.
Wow.
Yeah, that's the thing that happened.
Crazy.
I want to headbutt you. Get up here. What the fuck are you doing?
This isn't going anywhere, you guys. This isn't going anywhere.
That's fucking epic.
Do a pose. Do a pose. Do a win pose.
Who next wants to suffer my
Oh,
liberal
shit.
arts wrath?
Oh shit. Oh. Oh
No!
What the fuck? Wait.
It's all breaking
I'm
apart.
Luchador, aren't I?
No.
I'm dad? Oh, I totally thought I was Luchador.
So you
Oh,
thought
shit.
you were punching
I
yourself.
thought I was punching you. We should probably wrap this up soon too. Let's finish this iteration and then we will call it a night. Oh my goodness! No! I'm on top of you! No! 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 Shit. Scott, you gotta take over. Oh no.
No, it's
I'm
mostly,
hanging on.
like,
Why
basic
am I hanging
Newtonian
on by a thread?
Physics.
I just threw myself off. I think maybe the controls are changing.
Huh? No, they just really wonky.
It's just different. I think it's different between the controllers.
Oh.
So it's like whenever we switch, it's like, what is happening?
You're comparing the dog to an electron?
No!
He has an excited and a non-excited state. After a while of being in an excited state, he goes to a non-excited
Yeah,
state. So Martha is a non-excited state.
it's true. Martha is a quantum object. She is simultaneously always excited and not excited. No!
Martha wants to replace that.
No! 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 Fuck. Alright,
Alright.
there you go.
Alright.
I feel like I'm
bring
the
it
only one
back.
who's figured out all the moves.
So the last time I played this, the controls were very different.
Really?
Oh, this one's fun. You can throw each other into some grinders.
Grinders. What are you doing? How are you doing that? How are you? Eric.
No! Oh, shit. Okay.
Oh.
And that is being ground up into tiny bits.
Fuck you, Dad!
That's
Oh.
so fucked up. Oh, shit. Okay, we started a new one. Let's finish this up and then.
I heard you were playing and
yeah.
canceling it.
We totally.
Okay, Dad's
kept on
Dad's
going.
like driving the car or something.
It's true.
Ugh.
Don't make me turn this car around,
Dad
son.
keeps wanting to like grab onto things.
Ah!
No, you don't, Dad. This is what I get for luchador school. I've been working out.
Yeah, this is fucking training, right?
Come here. Get. Oh. I'm gonna see you to the luchador. Oh.
That pun.
That was bad, I know.
That pun.
No, God, Dad, why are you beating me?
You're dead.
You're
dead.
Wait, are you playing the dad right now?
Yes.
I am
That was
dead.
a fucking dad joke if there ever was
That was
one.
a dad joke.
That was great. Yeah.
Oh,
Oh, luchadorable. Oh.
Dad's having a rough time.
I know.
Dad's in a rough patch of his
Oh
life.
no! Get out of there.
Oh.
Oh! Quicksand.
Oh. Eric has no mercy. I
No.
don't,
Never fight a son scorned.
don't
Yeah.
understand.
Especially one with a liberal arts degree.
Stay away.
Yeah. You
Stay
were
away
once
from
a
me.
bouncer, so.
Stay away from me.
you
Oh,
don't fuck
God.
with Eric.
No. Nope. No.
No!
Oh!
No. I just want to live in peace. I just.
Oh, live in pieces in the
There's
grinder.
Lucha
Lucha
Lucha don't. There's no- How do you keep putting me in there? I'm trying this whole time. Get.
Ow!
Get.
No! Oh, you're out. And you're out. Woo!
Get. I'm gonna get you. Eric, I'm gonna get you. You can watch this. Come on.
Oh,
No,
come
you
on, Dad.
fucking don't,
Come
Dad.
on, Dad. Let's do this.
You can't tell me what to do. You can't tell me what to do.
This is for that time you forgot my birthday.
Oh, get in there. Just get in the grinder. Eric,
Just
get
do
in the
it
grinder.
of your own volition.
Just get in the grinder.
Oh, no!
I just.
Whoa.
Whoa.
That laugh was terrifying.
Oh no.
Okay.
I didn't realize this, but I'm happy evil.
I don't want to play Pokemon against you now.
Wait, my controller.
Yeah, I don't know what's happening.
My controller's.
Seriously, Dad, see he's got the he holds on to something.
Oh, my
Yeah.
controller came out.
Oh. That's not. Yeah, you totally did. What the fuck?
I laughed. My
Oh,
controller.
what?
Looks like I didn't even have to do anything.
How did you end up in there?
I just jumped and it went in there. Get out of there!
My controller
What are
isn't
you
doing anything.
Why are you holding on to shit? Is
My controller isn't doing
plugged
anything
in?
anymore.
Is my controller plugged in? Okay. I think we might have died.
Into nothingness.
I don't know.
It's like
I'm
continuously
too
holding
drunk
on
to
to
stand
it
up now.
too.
Yeah, I know.
I think it
I'm not
kinda
doing
fucked up.
anything.
Yeah, I think
you're
it
not.
fucked up.
You're just you're taking a time out. You're taking a time out in the corner while Dad tries to figure his shit out.
That's way too real.
Right? Yeah.
Yeah, it's like the controls aren't even working actually. It's fucking up. It's fucking up.
Everything is terrible.
Yeah, I'm just gonna kill myself.
Just get into the garage.
Yeah, just get rid of yourself.
And just wait
Don't
for
bother.
the sweet release.
I'm not
Why
even
put in the energy?
I'm not even pushing
The sweet
any buttons,
release of death.
and I'm stuck.
I think you
Sweet
have to
rel-
actually actively try to punch.
It's
No,
like,
it doesn't matter.
You
It's
have
stuck.
to hold down a button in order to hold on.
Yeah.
Yeah.
Oh shit.
Alright, let's see if we're
Well, except my character's not trying at all. Why isn't it doing anything?
Okay. It must have just
It's
Yeah.
it's
Right. We
I
gotta
put it back
call
in,
it a
though.
night anyway. Yeah. I'm just gonna kill myself one more time.
No, Dad!
Ow!
Just as we were bonding
I know.
by murdering each other.
Okay. All right. That looks like the end.
Ooh, that's a
Ooh,
cool
that level looks fun though.
The blade level.
I don't know if our shit's working though.
Let's
Is it
get
ever?
some.
Anyway.
Let's get some key lime.
Okay.
Key lime pay.
Key lime pay. Let's make those
Let's get some
fucking
key
key
lime
limes
pay.
pay. Okay. All right. Let's we'll switch back to our main camera here for a second. While we say
I'm
good
spent.
night, thank you guys so
spent.
much for watching. We had a great time. I think we got a little drunk, so that's fun times. Yeah.
It was good.
Victory dance a la Gang Beasts to close it out. That's right.
That was, yeah, that's more like it.
Yeah, that one.
Yeah.
Yeah, right. Yeah.
No, it's more like this.
You do the. Okay. Oh no, I don't want to. I don't want to do it.
Like a wave and particle one.
Yeah. Wave and particle. I don't know. I'm not sure what's happening there. Anyway, okay. Thank you guys all for watching.
Bye.
Later.
We'll see you next week. We're going to be talking about language.
Ooh, I like language.
So next week we'll be talking about language.
We've been doing it the whole
This whole
A
time.
very clever
Imagine that.
deception.
That's right. All right. Good night, everybody.
And
Thank you guys for watching.
later.
Woo, 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 woo.
High five myself.
All right. Yeah, I'm glad we were able to resolve some daddy issues as well.
Were we?
Yeah, I don't know. They might
Please
be
stop.
ongoing.
Please stop.
All right. Good night, everybody.
Night.